The second and 10th terms of an arithmetic sequence are, the second term is 3.8, and the 10th term is -1. Find the common difference. Well, usually when I deal with arithmetic sequences, I look at this formula right here. A sub n is going to equal the first term plus whatever term I'm talking about minus 1 times the common difference. Here's the thing. I don't have the first term. I don't know the common difference. What I do know is I have the 10th term. That's good. So what I could do is I could just be like, you're now the first term, and you're now the 9th term, and no one's going to know any different, right? Just shift it over once, because all I have to do is find the common difference. So if we just make believe that you're the first term, and if you're the first term, then you're no longer the second, that means you are now the 9th. So I can do this. So what I have is I have the fact that a of 9 is -1. I know that. I don't know the first term, except that I do. It's 3.8, because I just made it up. 3.8 plus the fact that we are using the 9th term minus 1 times the common difference. Now I have enough information to do the rest. -1 equals 3.8 plus 8d. Let's subtract 3.8 from both sides minus 3.8. You become -4.8 equals 8d. Divide both sides by 8. Divide both sides by 8. And -4.8 is basically the same thing as what's 40? 6? -0.6? It's going to be my common difference. So there you go. So we were a little clever on this. We're clever kids. Consider the arithmetic sequence a of n with the following terms. You have a sub 5 equals that. You have a sub 11. So the 5th term is 12.4. The 11th term is 34. Determine the first term. So usually when I see problems like this, arithmetic sequences, I write out the formula for the arithmetic sequence and see what I have. And the problem is I don't have the first term, and what's worse is I don't have the common difference. But I can find the common difference because the 11th term is 34. If I subtract out 12.4, I know that that skips 11 minus 5 stuff. And if you're looking at that saying, isn't that the average rate of change? It is, because the average rate of change is going to give me the common difference between two numbers. So I'm using the average rate of change formula to find the common difference. So 34 minus 12.4 is going to be, what is that, 21, 9 plus 10, 0.6 over 6. So that is 3, because 6 goes into 18 3 times. That gives you 3.6 left over, 3.6. So that is my common difference. My common difference is 3.6. Now I have enough information where I can do the rest of this. So let's rewrite the equation over here. I want to find the first term. I already know that the 11th term is 34. So let's just say let's do the 11th term. Okay, a sub 11. And the reason why I kind of want to do that is because I will do 11 minus 1, which is 10. Life is going to be a lot easier. So if I use the 11th term was 34 minus a sub 1, which is what I don't know what I'm trying to find, plus the fact that we use the 11th term minus 1 times the common difference, which we just found. 34 is a sub 1, I don't know, plus 10 times 36. 3.6. I'm looking at that like something's not right. 3.6. That's going to be 34 equals a sub 1 plus 36. There we go. Freudian slip. Subtract 36 from both sides. Subtract 36 from both sides. And your first term is -2. So as long as you don't make stupid errors, you'll be all right. A portion of the graph of the arithmetic sequence a sub n is shown below. So arithmetic sequence a sub n, let's just write that out. A sub n equals a sub 1 plus n minus 1 times d. What do I know? A sub 1 stands for the first term. The first term is here, not here. The first term is not 10. Let me be clear. The first term is not 10. The first term is whatever this guy is, which appears to be 8.5. So a sub n equals 8.5 plus n minus 1 times the common difference. Every time I move over, I go down 1.5, so the common difference is negative 1.5. So it looks like they want us to kind of shift that over. So the actual formula is going to be 8.5 minus 1.5 to the n minus 1. Okay, so you look like you, but you're not. Negative 5 minus 1.5 n minus 10? Yeah, I don't know. I'm going to go back to that. 3 doesn't look like that. However, if I distribute that negative 1.5, I now have 8.5 minus 1.5 n plus 1.5, which gives us 10 minus 1.5 n. So it's definitely 3. 2, I don't see it. You would have negative 1.5 n. 2 would be negative 5 minus 1.5 n plus 15, which no way becomes 10 minus 1.5. Well, I'll be doubting Thomas over here. What a stupid problem. Maybe it's because the problem itself is not the stupid one. Maybe it's just me. A local community has a new text alert system that residents can sign up for. The table gives values of P of T in the number of residents for selected values of T in weeks since the community started the system. If a sequence is constructed to represent these data, because it's plural, which of the following best applies to the situation? So it looks like what I'm doing is I am definitely exponential. Am I multiplying 1.5? Yeah, I am multiplying. Well, 40 times 1.5 is 60. 60 times 1.5. So I'm multiplying 1.5. We're going to use, they want us to use what looks like to be a geometric sequence, so I'll set that up. A sub n equals a sub 1, the first term, times r to the n minus 1. Okay. Why they're using n and not t, I'm not sure, but not my problem. Let me see. I determined that the common ratio is 1.5, but they want us to write it out as 3 over 2. The first day is actually 60. So a sub n equals 60 times 3 over 2 to the n minus 1. Which is neither of those. So it's definitely not you and it's definitely not you. So my job is to now figure out, all right, well, which one of these is that? Well, if I were to look at it like this, all right, if I were to multiply, or better yet, rip this out and say, look, I don't like the n minus 1. Let's get rid of the n minus 1. Let's get rid of the n minus 1 by ripping those apart. So I can make it 60 times 3 over 2 n times 3 over 2, and if you're to the negative 1, and if you're wondering what did he do, what he did is originally if you have two terms of the same base being multiplied together, you add the exponent. So going in reverse, I did that. Now what I can do is I can say I have a fraction to the negative 1 power. Flip that. 60 times 3 over 2 to the nth. Flip that, making it 2/3. 2/3 of 60 is 40. So a sub n equals 40 times 3 over 2 to the n. Now, maybe I did too much. And some of you might be like, well, didn't we also learn, sir, didn't we also learn that an exponential function looks like this? Y equals a times b to the x. B is your common ratio, so you already knew it was 3 over 2, which automatically eliminates you because you're 2 over 3. So that's that. And isn't A what this whole thing would be if x is 0, so 40? Couldn't you have just done it that way? Yeah, we could. But when I saw the A sub n's, I just was like, oh, well, maybe they want arithmetic or geometric sequence stuff, and I went with it. I was wrong. It worked out in the end. But now you have two ways of doing the same exact problem. So you're welcome. Like and subscribe. The graph and explicit formula of a geometric sequence are shown. Which of the following statements must be true about the values of B and R? Well, here's the thing. We're going up and down and up and down and up and down and up and down. The only way that happens is if R is negative. Why? Well, because if you have like negative, actually no, B is going to be negative and R is going to be negative. Holy cow. All right, so let's backtrack. R is negative. Why? Because if you were to plug in -1, you could get negative. And then if you square it, it's positive and then negative. But here it is. Instead of plugging in 1 and getting a negative, we actually get a positive, which means B has to also be negative. So if I were to plug in, these guys, it goes up and down, up and down, up and down, up and down in its reverse form. So both of them have to be negative. What a strange problem indeed. The table above gives values of an arithmetic sequence. Which of the following is an equation of a linear function that could represent the sequence? So what we have going on here is we have point-slope form. So if you remember from back in the day, point-slope form looked like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. But this is a slight manipulation. So what I'm going to do is I'm going to use this information. I'll call you x sub 1. I'll call you y sub 1, right? That way I can plug stuff in. And is that looks like they want me to use 3 and 6? Yeah, maybe. I don't know. We'll find out. And what I also need to do is I need to find my slope. So the slope can be found by doing something like 8 minus 6. This is the slope formula. 6 minus 3. This is the slope formula. 2/3. This is the slope formula. And then when I plug stuff in, I get y minus y sub 1, which is 6, equals 2/3 times the quantity x minus x sub 1, which I called 3. So I need a slope of 2/3. So not you, yes you, not you, yes you. And I take it back. They actually don't want me to use 3 and 6. They want me to use 6 and 8. So why don't I change this? Why don't I make you my x sub 1 and you my y sub 1? So now I have, watch me. I'll turn you into an 8. I'll turn you into a 6. But when I add 8 to both sides, it now will look like this. Y equals 8 plus 2/3 times the quantity x minus 6, which is going to be b. So kind of weird. The process that I used to do it wasn't, as exact as I wish it would be, but, that's what you do when you steal problems from the internet. Nyla purchased stock in a new company and wants an equation to estimate the value of the stock in the future. Good for you, Nyla. She notices that the value of the stock increases by approximately 0.2% each week. At the 6th week after purchase, the value of the stock is that much. Write in a function in the form f of x equals y sub 1 gross, where f of x is an estimated value of the stock, x is the number of weeks after the purchase, and x sub 1, y sub 1 is a point. All right, so you would be a point. 6th week, well, hold on. What does it want week to be? X. So yeah, you would be a point. 6 2475. So let's do that. 6, 2475. Okay, that's the x sub 1, y sub 1 that they want me to use. So let's set up what we have so far. F of x equals y sub 1 is 2475. R is going to be, does it tell me what R is? Does it tell me what R is? No, but it's going to be my common ratio. And if something increases by 2.2% each, that means you're going to multiply it by 1 plus 0.2%, which is not 0.2. That's 0.002. So my common ratio is going to be that gross number right there. So f of x equals y sub 1 times the common ratio, 1.002, to the x minus x sub 1. So I guess we're just going to use regular x minus 6, which appears to be u. Kind of a strange problem. I don't like it. The graph above represents the amount of caffeine in an adult's blood after they drink 1 cup of coffee, where X is the hours since consuming the coffee and Y is the amount of caffeine in milligrams. So hours, milligrams, great. Which of the following equations defines the function in the graph? So without doing too much, what it appears I have is at 0, I have 100. Okay, so the first things first, if you're looking at an equation like this, okay, which is what I have. All right, that's my initial amount. So A is going to be 100. So Y equals 100. B is, I don't know yet, but what I do have is decay. So decay means B has to be in between 0 and 1, which excludes U and which excludes U. And so it's going to be to the x power. Now, I have to choose between 0.85 and 1.5. So if I were to plug in 1, right, into U, I would get 100 times 0.85 to the first, or 100 times 0.85, which is going to be 85. So let's see what happens when I go to 1. Seems to match up with 85. So, yep, you're my guy. If I were to try C, I would do the same thing and get, let's plug in 1 and 0.15, and that's going to equal 15, which is not what I want. Okay, and this also makes sense because this is saying that we are going to decrease, but not at a huge rate. You know, you're losing 15% per, what is this, hour? So that's what's going on here. This is like you're losing almost everything per hour, and that's going to be a huge dip, which is not what we have. So my guy is going to be A. Which table could represent values of x and their corresponding values of f of x for a decreasing exponential function? All right, so first things first, I need to find a decreasing function, and I need to make sure it's exponential. So if I look at you, you're increasing, you're decreasing, you are decreasing, and you are decreasing. Now, something that decreases exponentially means you multiply the same number to get to the next, to get to the next, to get to the next. So it's very, very, very much like geometric sequences. Okay, so I'm going to wait on you because I don't like these numbers. I'm going to go with the easier numbers. What am I doing here every single time? It looks like here I'm going from 3 to -1, from -1 to -5. I'm subtracting 1 here, which means you are not geometric. You are not exponential. You're neither. This is going down by 1, and then going down by 3, and then going down by 5, which indicates quadratic. So let's see what I have here. And let me blow these numbers up just so I can see it better. That looks like 3, I'm hoping 84. That's 192. That is, what is that, 96. 96, and that is 48. Okay, my eyes are so bad. It looks like what I'm doing every single time is I'm dividing by a 2 or multiplying by a half, which is what makes this exponential, right? When it's linear, like this guy, you add the same number every time. When it's quadratic, you add the same number, but that has, in this case, a difference of 2. So, and this guy was was increasing. So B is the only one that decreases and decreases exponentially. So that's going to be my guy. I can't talk. The table shows values from an exponential function in the form y equals a b to the x, where a and b are positive constants. Which statement best describes the exponential function? So without doing too much, let's analyze what y equals a b to the x means. A is always going to be your starting point, your initial value, and b is going to be your common ratio, which you multiply every single time to get from one number to the next. In this case, my initial value is going to be 0.6. Okay, so I'm starting out with 0.60. It looks like every single time to get from one number to the next, I'm going to be very careful. I don't just divide by a quarter. I divide by a quarter over an interval of 2, but I don't think that's going to be necessary. I mean, what we definitely have is we have decay. So what's going to happen here is B is going to be some type of decay where we divide by 4 every 2, which means I guess I could legitimately say that I divide by 2. So if I were to force like a 1 in there and put a 0.30, that would work. So what I have is I'm dividing by 2 every time. So you're a half. So that's the equation I came up with. Is that what it wants me to do here? No, it just wants me to answer some logical questions. The function demonstrates exponential growth. No. The function demonstrates exponential growth. No. The function demonstrates exponential decay because A is in between 0 and 1. Well, that's not why. That just happens to be the case here, but that's not why it's exponential decay. It's exponential decay because B, my common ratio, is between 0 and 1. So it's easy to select C based off of the numbers that I got, but C is not why it's exponential decay. D is why it's exponential decay. DK Donkey Kong. The limit as x approaches negative infinity of 1/3 times 1.2. Oh, okay, so this is what we have. We have ourselves exponential growth. So we have ourselves something in the form a times b to the x. Now, anything that is in that form where I have growth here, where b is greater than 1, is always going to look like this on a coordinate plane. Let me get a different color, give or take. Now, what I don't see here is I'm not adding or subtracting anything. So I'm going to 0 as I move to the left and positive infinity as I move to the right. What do they want? They want me to move to the left. So as I move to the left, I flatten out at 0. Nothing crazy there. Just because that's a 1/3 doesn't mean anything. The only thing that would change this is if I add or subtract a number here. That would shift it up or shift it down. But shifting it left or right makes absolutely no difference because I would still end up at 0 all the way to the left. The function f is given by f of x equals 16 times 49 to the x, which of the following is an equivalent form of f of x. So let me write it out. F of x, 16 times 49 to the x. Now I have a 16, which I know is 4 squared. I have a 49, which I know is 7 squared. 16 is also 2 to the whatever, but let's see what they want me to do. They want me to change 16 to 4 or keep it at 16. Well, 16 is 4 squared, so neither of you. So let's change 49 to 7 squared, and let's see what happens. So 49 is 7 squared to the x. When you have an exponent to an exponent, you multiply the exponents. So this can be written as 16, 7 to the 2x. which is D. The function f is given by f of x equals 3 to the x minus 3 as the exponent, and its graph is shown above. So, first things first. Okay, this is the same thing as 3 to the x, but since you have x minus 3 inside the parentheses, you move to the right 3. Okay, move to the right 3. Is that at all what I want to do? No. Which of the following is the equivalent form? So that's not at all what I want to do. So I just have a picture for no reason whatsoever. What they want me to do is they want me to turn 3 to the x minus 3 into one of these guys. Now, whenever you get two things being added together as an exponent, it's because you multiplied terms of the same base. So now that I don't need this anymore, let me back it up a little bit. Let me go in reverse. If I gave you a problem like 3 to the x times 3 to the fourth, you would say these are terms of the same base. Let's add the exponents 3 to the x plus 4. What must these be in order to get something like this? Well, that 4, if that was a negative 3, would have me adding the exponents, and x plus negative 3 is x minus 3. So I can rewrite this as 3 to the x times 3 to the negative third. Now, is that an option? No, 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 and no. Now, what I do know is 3 to the negative third can be written out as 1 over 3 to the third. So I have 3 to the x times 1 over 3 to the third. Is that an option? No. So let's take it one step further. 1 over 3 to the third can be written as 1 over 3 times 3, 9 times 3, 27. So is 3 to the x times 1 over 27 an option? Sure is. So what's the point of this picture right here? Nothing. Nothing at all. Tricked you. Given that m and n are positive integers, find the value of n plus n if this happens. Gross. All right, so let's move stuff around. I mean, let's do a little bit of function manipulation and see what happens, what we get. So I'm going to write this out as 12. Okay. I'm going to move x to the negative n to the bottom and make it x to the positive n. Whenever you have things being multiplied to an exponent, you multiply exponents. In this case, you would distribute that. So that parentheses down there becomes m to the negative 2 x to the positive 6. I can move u upstairs, so 12 over x to the nth. I can move u upstairs and make u m squared. And what was that? X to the 6th? X to the 6th stays on the bottom. So what I have is 12 m squared over x to the n plus 2. No, I'm sorry, n plus 6. N plus 6. I'm looking at that guy. That's supposed to match up with 108 over x to the 9th. 12 times what is 108? 12 times 3 squared is 108. 12 times 9 is 108. That would make m 3. Because 12 times 3 squared is 12 times 9, which is 108. Great. If I were to replace n with 3, I would get 3 plus 6, which is 9. So what a strange problem this is indeed. But that's not what I want. I'm still not done. I almost circled B and was like, oh, hooray. I'm supposed to find m plus n. M plus n is 3 plus 3, which is 6. Very tricky problem, very difficult, but, you know, we did it, and it was so much fun. Which of the following expressions are equivalent to negative 2? Well, let's take this one step at a time. I have negative 1 over 32 times negative 1 over 5. Now, first things first, whenever you have a negative exponent and a fraction living inside, flip it and make it positive. Now, when you take a number and take it to the fraction, whatever that number is going to be a root. So this is asking for the fifth root of 32, negative 32. The fifth root of a negative number is still negative. What times what? Times what times what times what? 5 times is 32. 2 is. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 32. So 1 does pan out. Cha-ching! 1 does pan out. Let's take a look at the middle guy. We've got 4 to the negative 1/2, which could be written as 1 over 4 to the 1/2. And 1 over 4 to the 1/2 means 1 over the square root of 4, because you take that second root, the square root of 4 is 1/2. So is 2 an option? As my friends from Australia would say, nar. Let's take a look at this last one. We have negative 1 over 6 to the negative 1 over 4. So that negative exponent means we flip the inside. This is 1 over 6, my fault, 1 over 16. Let's flip the inside. So now that becomes negative 16 to the positive 1 over 4. If you were to take the fourth root of a negative number, it ain't going to work. Can't do it. So the only option that I have is just 1, and 1 only. Very interesting. Find the value of n such that f of n equals p of n. Well, let's set this up. 1 over 64 to the n plus 2 has to equal 4 to the negative 2n plus 6. Whenever you're solving equations and you have all these exponent things going on, and we're in this section, we don't know anything about logarithms yet, what we need to do is we need to set this up so that they have the same exact base. Now, I know 4 times 4 times 4 is 64. So the first thing I'm going to do is I'm going to rewrite that out to 1 over 4 cubed. That way, I can make that look like that and set the exponents equal to each other. Okay, so that becomes that. I can rewrite 1 over 4 cubed as 4 to the negative third times n plus 2. Whenever you have an exponent to an exponent, multiply the exponents. In this case, that requires you to do distributive property. So 4 to the negative 3n minus 6. Now let's bring this guy back down, because that is 4 to the negative 2n plus 6. If you have terms of the same base that are equal to each other, then your exponents are going to be equal to each other. So negative 3n minus 6 is going to equal negative 2n plus 6. Let's add 3n to both sides. So negative 6 equals n plus 6. I'm not showing my work, shame on me. I added 3n to both sides, so plus 3n to negative 2n is regular n. Negative 6 drops down, 6 drops down, subtract 6, and in the interest of space, negative 6 minus 6 is negative 12. Tricky. A taco making company has a fixed overhead cost of 50 grand. Ooh, for rent, insurance, and other expenses. It costs an average of 26 cents to produce each taco, assuming these are the company's only costs, which is definitely not true. Write a model to represent what the company spends to produce X amount of tacos. All right, well, if you have $50,000, okay, and that's you want costs, C is cost. Okay, you're going to start out with $50,000. However, you gain, it also costs 26 cents to produce each taco. So plus 26 cents per taco. Did I call that a letter X? X tacos. And is that all I have to do? Yeah. Strange problem. It's almost too easy, but that's what it is. It's basically asking for what's the cost if everything is going to cost $50,000, period, and then 26 cents per taco. That's how much you're going to spend per taco. So that's it. Don't overthink it. I kind of did, but don't overthink that one. That one's a lot easier than it looks. The table above shows the height of the ball with regard to time, and it bounces up and down. What type of model should be used to calculate the height of a ball as it is a function of time? Basically, if you're expecting, if you drop a ball and it bounces, and in this case, it bounces a little bit more, and then peaks out a little bit less, a little bit less, a little bit less. It's definitely not linear. Okay, since it goes up and then down, it's definitely not exponential, because exponential only looks like this, where it just goes up. It's definitely not logarithmic, because logarithmic goes like that, which means, it bounces up. It still increases, but slows down its increase, whereas exponential increases, and increases at a faster rate. This guy bounces up and down. So without doing any real math, I know it's quadratic because it goes up and then down. A statistician recorded the pregnancy rate of 1,000 U.S. women aged whatever to whatever. A linear regression was used to develop a linear model for the pregnancy rate over time. The figure shows a graph of the residuals of linear regression. Which of the following is true? Now, looking at these dots, okay, what you're looking for with a residual model is, do you have a pattern? Okay. In other words, if I were to give you a residual plot that looks like this, that's a clear quadratic pattern. So when you have a clear pattern, a linear model is not appropriate. So I don't see a pattern. I have a dot down here, 4 dots up here, 5 dots down there, 3 dots up here. I don't have anything quadratic. That's not that doesn't look cubic or anything like that. It's not like you're going to be like, oh, well, yeah, I could definitely do that. No, not really. I don't have any pattern. So since I don't have a clear pattern, linear is appropriate. So let's choose that. The linear model is appropriate because the residual plots demonstrate a clear pattern. No, linear is appropriate, but it's because it doesn't present a pattern. The linear model is appropriate because the residual plot does not demonstrate a pattern. Yep. The linear model is not. Nope. The linear model is not. Nope. So what you're looking for with residual plots is, do you have a pattern? No. Then it's linear. A series of 3 different data sets were modeled with linear functions. The figure above shows the graphs of the residuals of the linear regressions. Which of the following statements about the residual plots are true? What do we have here? We have something that looks quadratic. Okay. What do we have here? Something that looks mostly quadratic. And what do we have here? No pattern at all. Now, with residual patterns, if you have things that are patterns like you and like you, then it's not going to be linear. Okay, remember, these guys represent horizontal lines of best fit. So if I were to graph something like this, and all of a sudden I have a picture that looks like that, linear is not appropriate. Okay, all I did was took that guy and tilt it sideways and say that is the same as that, so that's definitely not linear. However, if I were to take this third guy, okay, and say, here, you're a line, and I have a bunch of dots scattered above here, and I have a bunch of dots scattered above there, and there's no obvious pattern, then linear is appropriate. So these guys, since they have a pattern on a residual plot, means they're not linear. Since this guy has no pattern on a residual plot, that guy is linear. So plot 1 and 2 are not linear. Plot 3 is linear. So plot 1, a linear function, is not valid because the residual plot does not demonstrate a pattern. That is true. What do I want? Which of the following statements about the residual plots are true? For plot 1, a linear function is not valid because the residual plots does not demonstrate a pattern. I'm sorry, it does demonstrate a pattern, so A is no good. For plot 3, a linear function is not valid. Nope, don't disagree with you, or agree with you. For plot 1 and 2, a linear function is not valid because the residual plot demonstrates a pattern. Agreed. For plot 2 and 3, those have nothing to do with each other, so I'm just going to cross you right out. In 2010, researchers published a study showing the crash risks of alcohol-impaired driving. They used data from that many car crashes to show the relationship between driver's blood alcohol and the risk of being in an accident. The data from the report was used to create an exponential model of the relative risk of car accidents as a function of blood alcohol. The data is shown in the figure above, and the error associated with the model is shown in the figure to the right, where the error is the difference between the actual rate and the projected value. Which of the following conclusions is best? Well, it looks like we have exponential, and our error seems to go really wacky whenever the blood alcohol is higher. Now, I would say, based off of this picture here, that you do have an exponential model. This picture shows a model, which means this picture is just not linear. Okay, if it shows an obvious pattern, it means not linear. Looking at the picture on the left, I know it's exponential because exponential looks like that. Okay, so an exponential model is not appropriate? No. It is better to overestimate the relative risk of alcohol impairment driving to ensure readers understand the dangers. I don't think that's what's going on here. I don't disagree. Because the error is greatly increased after a blood alcohol of 0.15, the model should only include the interval 0 to 0.15. Maybe. Because the risk of accident is so high after a blood alcohol of 0.15, the model should only include the interval between, no. So I guess C would be your guy, because after 15, like the data seems to be way off, and they might be like, you know what, let's just count everything up to here and not worry about that. So all that nonlinear talk had nothing to do with this problem, but this residual plot looking thing right here is pretty valid up to this point right here. And once we get beyond 0.15, it goes haywire, just like drunk driving is. In an experiment, the number of mold spores can be modeled using a geometric sequence. Very interesting. Where the first day of the experiment is day 1. If the population on day 6 of the experiment is 6,000 and the population is 20,000 on day 10, find the mold spore population on day 8. So what we're going to do, since this is a calculator problem, is we're going to use exponential regression. And once we find exponential regression, we should be able to take that equation and plug in 8 to find our total population. So let's step to the side and do that. All right, so for this guy, we are going to do exponential regression. Start out by hitting Stat, go to Edit, and we're going to type in the 2 data points that we have, 6 and 6,000. So let's do 6, move to the right, 6,000. And then we're going to do day 10. So they typed it out, worded it out, whatever you want to say, backwards. So just be careful. We're doing exponential regression, and I'm going to use this equation to plug in 8. So what I'm going to do is I'm going to hit Stat. I'm going to go down to 0, which I believe is exponential regression. There it is. But I want to use this equation again. So this is what I'm going to do. I don't really care what the equation is. I just want to use it. So as I hit enter, wherever it stores regression equation, that's what that means. We're going to go to vars. We're going to go to y vars function y sub 1. Now, yeah, this gives us our equation, but look how gross it is. Wouldn't it be nice if we could just take that and somehow plug in 8? Well, we can because there it is. By doing that vars thing, it plugs in our equation right there. And in order to find 8, maybe we could just go to our table by hitting second graph and going down to 8 and finding out that there's our number right there. So the answer is B in this case. All right, so since I got the number 10954 point blah, 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 let's round that down to 10954, and then B is going to be our answer. So exponential regression, geometric sequence, same thing on a calculator. Gustavo wanted to increase traffic to his website by buying ads on other websites. 1 month after buying his first ad, he had 4,200 visits to his website. 3 months after buying his first ad, he had 6,048 visits to his website. If the traffic to his website increases by a constant proportion every month, write a geometric sequence to represent this increase. Now, if you're looking at that guy right there, you should be thinking, all right, well, I'm allowed to use a calculator. That guy looks an awful lot like this because they basically are the same. This is exponential regression. So what we're going to do is we are going to run to our calculators and we're going to use exponential regression to write an equation. And then once we have that equation written out, we'll just fix those letters and stuff like that. All right, so Gustavo wants to make a geometric sequence, which is the same as exponential regression. So what I'm going to do is I'm going to go to Stat, I'm going to go to Edit, and I'm going to type in my 2 data points. 1 month matches up with 4,200. Okay, bada bing. Month 3 is 6,048, like so. Now, all I care about is the equation, so I'm just going to quit out of this. I'm going to go to Stat. And again, you're not looking for geometric sequences. Geometric sequences and exponential regression are the same exact thing. So if I hit exponential regression, go down to calculate, it gives me y equals 3,500 times 1.2 to the x, which, not using the exact letters, matches up with B. All right, so the equation that we came up with is y equals 3,500 times 1.2 to the x. So all we really have to do is, replace y with g of n and n with x. And we're not going to get that one, but we're actually going to get that one, which is B. I don't know why I circled the stuff in A. I just wanted to show that, g of n and regular n. But B is going to be our guy. Population of a town is shown in the table above. Consider the linear population for the town's population and an exponential model for the town's population. So I want to do this using linear regression, and I want to do this using exponential regression. And then once I do both of these, I'm going to see which one predicts a higher population in the year 2025. 2 things. I don't feel like plugging in 2020. I don't feel like plugging in 2022. So I'm going to use 0 for this. I'm going to use 2 for this. I'm going to use 5 for this. And I'm allowed to do that because I don't really care about what the equation looks like. I just care about what I get in the end. So this guy wants us to compare exponential models with linear models. So let's do one of each. You got Stat, Edit. We got to plug our points in. So instead of using 2020, I'm going to use 0 for 2020. And instead of using 2022, I'm going to use 2, which means when it asks me to do 2025, I'm going to use the value 5. Now let's plug in our other points. We've got 2,800. We've got 2,527. And then we'll quit out of it. Now let's calculate exponential first. So we'll go down to exponential regression. There it is. Enter, enter, enter. I am going to use this equation and plug in 5. So I'm going to go down to the store regression equation guy, hit vars, go to y vars, function, and now it's going to store that in y sub 1. So I'm going to calculate it. Boom. When I hit y equals, there's my equation right there with its unnecessary decimals. I care about what happens at 5, and whatever happens at 5, I could just find out by clicking table, and I have 2,166.6. So I'll write that down when I have the opportunity to write it down. That's my one guy. So again, the exponential model gave me 2,166 point blah, 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 blah. Now I'm going to keep the same values. And what I want to do is I want to do the same thing, but with a linear model. So I'm going to go to stat again. I'm going to go to calc again. And this time I'm going to go to linreg, which is 4. Enter, enter, enter. I want to store that again in the y equals part. So I'm going to go to store regression equation, the vars thing, the function thing, the enter, enter thing. And now when I hit calculate, that equation right there is in the y equals thing. So I care about what happens in 2025, which means the year is 5. So second table. And now the value that I care about at 5 is 2,107. 117.5. So I'm going to write those numbers down and then come up with my answer in a second. So the exponential regression model gave us 2,167, give or take. Of course, I'm rounding it because of the fact that it's a person, and I want to take 0.6 of a human being. And the linear model gave us 2,118. So this is about 50 some more than that, or in this case, 49 more. So the exponential model is a higher population by 49 residents. That seems to be the answer that I wanted. So I'm going with B, baby. Which statement best describes the exponential function defined above? All right, so we have something in the form a times b to the x minus 3. I don't have to write this out. Now, this is a calculator problem, but I don't think I need a calculator unless I want to use one at the very end to double check my work. G demonstrates exponential decay. Well, this guy wrapped inside the parentheses taken to the x power says, nope, since you're 1.5, that means you're greater than 1. This is growth. So this is not going to be decay, and this is not going to be decay. It's growth because the x-intercept is positive? No. It's growth because a is greater than 0, and b is also positive. So if this was negative, it would take that guy and flip it upside down. But since b is positive and greater than 1, and a is positive, we have exponential growth, so D is going to be my answer. Now, let's throw this into a calculator and make sure everything is good. All right, so even though I didn't need my calculator, let's type it in and see what happens anyway, just to make sure that we got D correct. So I'm going to type out parentheses 1/4. I like to do extra parentheses with fractions because I'm nervous. 3 over 2 is going to be my growth factor. To the x is right there, scooch to the right, minus 3. And let's hit graph and see if D seems to make sense. G demonstrates exponential growth because A is greater than 0 and B is greater than 1. Well, A is greater than 0, B is greater than 1, and yeah, that's exponential growth, so I'll take it, baby. An exponential function in the form f of x equals a times b to the x has a growth factor of 1.56 and crosses the y-axis at 0.85. On the closed interval 0,4, what is the maximum value? All right, so let's set up our equation first off. We have something in the form a times b to the x. This is going to be your initial value at the very beginning of everything. In other words, the beginning of everything happens when x is 0. So y equals 0.85, a positive number. The growth factor is 1.56, so that's going to be my b, 1.56 to the x. So what I have is I have something in the form of exponential growth. Now, it wants me to, on a closed interval 0,4, find the maximum value of f. Well, this is going to make sense that if I have 0 to 4, 4 is going to be my maximum. So what I have to do is I just have to throw that in my calculator, plug in 4, and see what value I get. So we're just going to plug in the equation that we came up with. We came up with 0.85 parentheses 1.56, close the parentheses, to the x power. Now we care about what happens between the intervals 0 and 4. So when I hit graph, that's exponential. And so as you move to the right, your value gets bigger because this is exponential growth, because the growth factor is greater than 1. Now, my maximum is going to happen all the way to the right of the rightmost part of the interval. So basically, my maximum happens at 4. So if I go and type out second trace, hit value, hit 4, I'm going to get that number right there, which matches up with the answer C. So basically, you're finding the maximum knowing very well that your maximum is going to be all the way to the right for this one. And when I did that, I get 5.034, so the answer is C. F of x is an exponential function in the form f of x equals a times b to the x plus c. Select values of f of x are shown in the table below. A is 400. Okay. So A is 400, so let's write that out. F of x equals A times B to the x. A is 400, so let me quick change that. I wasn't thinking. 400 B to the x plus C, which is, I don't know. What I do know is if I plug in 0, that's going to make this part go away and become 1. So what I can do is I need to find C. I need to find whatever C makes this work. So what I'm going to do is I'm going to let x equal 0. And I know when I plug in 0, I get 373. So 373 is going to equal 400 times b to the 0th power, which is 1. If I subtract 400, that gives me C is negative 27. So that gives me an equation of y equals, or f of x equals 400 b to the x, which is what I need to find, minus 27. So what I'm going to do is I'm going to take all of these b values, plug it into my calculator, and test out 400 times 1.25 to the x minus 27 and see if that guy matches up. And if it doesn't, then I'll plug u in for b and try it out. Then I'll plug u in and try it out. Then I'll plug u in and try it out. So let's try a and see what happens. So let's test out a to make sure that a works. The equation that I'm going to use for a is going to be that 400 that I was originally given. A gave me 1.25 as my b, so parentheses 1.25, close it, to the x, and make sure you move to the right and not put it in your parentheses or exponent area. Subtract out 27. Now, in order for this to work, I really want to look at my table of values for 0, 1, 2, and 3. So let's go to second graph, and 0 matches up, and so does 1, and so does 2, and so does 3. Look at that. The answer is A. It worked. Hooray! A is my answer. Oh, how nice. An exponential function of the form y equals a times b to the x passes through the points 529 and 1588. Find the initial value a of the exponential function. So I'm just going to run to my calculator and do exponential regression using these two guys as my two data points. So this one is just a good old-fashioned exponential regression problem. Hit stat, hit edit. My 2 points are 529, enter, enter. And then my other guy is 1588, enter, enter. Quit out of it. I don't need to use this equation later. I just need to find the equation. So let's go to stat. Let's go to 0, which is my exponential regression. And it gives me the equation once I go to calculate. Y equals 16.64 blah, blah, blah times blah, blah, blah to the blah, blah, blah. But the only blah, blah, blah I care about is that 16.6477, which rounds up to 648. The answer is C. So according to this, the A value that I got was 16.648, which is C. Pretty easy. A radioactive element has a half-life of 11 years. In other words, every 11 years it goes by half. If 20 grams of the element is remaining after 25 years, what was the initial mass in grams of the element? So this is what I'm going to do. I'm going to write out the half-life formula that I know how. So this is an exponential form formula. Okay, A is always what you start out with. B is going to be your growth factor, and X in this case is going to be time. So do I know what we start out with right away? No, but what I do know is we end with 20. I don't know my initial amount. I do know that I'm taking a half of it every 11 years. So how do I show every 11 years? By doing X over 11. Now, I care about what happens at 25. So I'm going to rewrite this to be 20 equals A times a half to the 25 over 11. So this is how I'm going to handle this problem, because now I need a calculator to take over. I'm going to find 1/2 to the 25 over 11, get some number, and 20 divided by that number is going to get me my A. So let's see what happens. So now I'm at the point where I really can't do much without a calculator. So I have two calculations that I need to do. First thing I need to do is I need to figure out what 1/2 to the 25 over 11th power is. So I'm typing that out. If I can just type and not make a little typo, 25 over 11. It's going to give me that number right there. Now I'm going to take 20 and divide that number from 20. So I can divide that number if I want to by hitting second and then that little negative symbol there. And what that does is that uses that whole number so I get more accurate of an answer, which gives me that guy right there. And darned if that isn't awfully close to C, which it is. So that's my answer. So the A I got is 96.6, I think it was 665 or something like that. So that gives me C. Close enough. I mean, you're not looking at exact when we're dealing with some rounding error, but no, that's my guy, and I'm sticking with C. C is the answer. C it is. C. C means yes. Ooh, let f of x equals 8 over x minus 2 and g of x equals 4 over x minus 4. Identify the domain of f of g of x. All right, so what f of g of x looks like is you take f, you write it out like so, but anytime you see an x, you replace it with g. So it's going to look like this. Every time you see an x, you replace it with g minus 2. Now, this tells me right now, x minus 4 in the denominator, 4 can't have it. 4 is not going to be allowed in my domain, so that's part of my answer. Moving on. I'm not done yet because I have a fraction underneath a fraction bar, and it's just I got to combine fractions, so I'm going to do that. I'm going to multiply this guy by x minus 4 over x minus 4, distribute u, and that gives me 4 over x minus 4. By the way, 8 is still on top. I don't know why I forgot to write that out. 8 is still on top. Distribute that, you get negative 2x plus 8 over x minus 4. Now, since I distributed the negative 2, you're adding here. Now that I have the same denominator downstairs, I can combine the numerator, so 8 still lives upstairs. Okay, 4 minus 2x plus 8 is 12 minus 2x over x minus 4. Now, I'm going to quick move this 8 up here and put it over 1 so I can visualize a fraction over a fraction. Whenever you have a fraction divided by a fraction, multiply the top by the reciprocal of the bottom. So I'm going to multiply this by x minus 4 over 12 minus 2x over x minus 4 over 12 minus 2x. What that does, all of this cancels out and leaves me with 8 times x, 8 times negative 4, not that that really matters, 12 minus 2x. Now I have a brand new denominator. And according to this brand new denominator, if I set u equal to 0, add 2x, divide by 2, now x isn't allowed to equal 6 either. So my domain is everything but 4 and 6, which could be written out as negative infinity to 4, union, 4 to 6, union, 6 to infinity, which is u. Yeah, not very pleasant of a problem, but boy, was it so much fun. The graphs of f of x, boom, and g of x, boom, are showed in the figure above. Evaluate f of g of 3. Now, this can be written as f of g of 3. So what I'm going to do is I'm going to find out what g of 3 is, and then once I have a number, I can find f of whatever that is. So according to this, g of 3, there's 3. G of 3 appears to be negative 3. So g of 3 is negative 3. So f of g of 3 is the same as f of negative 3, like so. So let's go to f. Let's go to negative 3. F of negative 3 appears to be 4. D is my answer. Ooh, wasn't that nice? Express the given function as a composite of two functions f and g such that h of x, u, is f of g of x. All right, so this is what I see. I have a function living within a function. G would be that guy living inside f, which would be that guy. So I view this as f is probably the square, or the cubed root rather, of stuff, and g is the stuff living inside it, which is x squared minus 9. I have to put x in there. Can't forget that. So they don't want me to write it out as the cube root. They want me to write it out with a 1/3 as an exponent. So C seems to be the guy that I have. So yeah, don't overthink this. Just, it's a function within a function. Don't overthink it. Identify all statements that are true. Ooh. All right. F of g of x. Let's find f of g of x. This is going to take us a minute. F of g of x means I take f, and for every, writing it down. For every x that I have, replace it with g. So just take that x and write out g. Okay, I can handle that. G of f is you're going to take g, which is this, and replace every x with f, so they're the same. Oh, how nice. So not you. 2 says g of h. So let's find out what g of h is. G of h means I start out with g and replace the x with an h. So instead of x minus 4, 3x plus 4 minus 4 over 3. These guys cancel out. 3x over 3 is just going to be x. So that's g of h. Let's see what h of g is. H of g means I start out with h, replace every x with g. Don't forget the plus 4. These guys cancel out. And then I'll have x minus 4 plus 4, which is just x. Oh, how nice. Of course, I have to keep going because it's never that simple. H of j has me start out with that. So start out with h, Substitute j for every x. This is h of j. So you get 9x minus 12 plus 4 is going to be 9x minus 12 plus 4 is minus 8. Now let's do j of h, which has me start out with j and replaces every x with h. So 9x plus 15, I'm sorry, plus 12 minus 4. Oh, we finally have one. We have one that doesn't match up. So you don't work, friend, and you're going to be my guy. The figure above shows the graph of the function f on the domain between 0 to 9. There it is. If the inverse of f looks like that, what is the value of f inverse of 4 minus f inverse of 2? Well, here's the thing. If I say like f of x equals a number, okay, like for example, x and y, like if I were to look at this and say, all right, well, 0 appears to match up with 0, and 2 appears to be 1, and what do I care about? What else do I care about? 4 appears to be 2, and that other 4 is probably going to show up. So let me see. 6 appears to be 4. The inverse would be if I were to completely flip these guys around. Completely flip them around. All right, so 0 is still 0, but 1 is now 2, and 2 is now 4, and 4 is now 6. Now, why did I use those exact numbers? Why did I see to it that I had 2 and 4 over here? Because now I have 2 and 4 on the left. So what I do now that I flipped everything, now that I found out, and basically that's how you approach this problem. You're saying, oh, if I want the inverse, then what I want to do is swap the x and the y values. So on this picture, I care about when y is 4 and when y is 2, and then swap them. So now I have them swapped. And so when I want to do this, f inverse of 4 is 6. Write that down here. F inverse of 2 is 4. And 6 minus 4 is this little tiny 2 right there. I've heard of Tiny Tim, but Tiny 2? Now that's a Christmas story that I'd want to watch. I hope that problem made sense. The graph of the function f of x is shown in this figure. On which of the following intervals is f inverse defined as f inverse greater than f of x? All right, well, let's do this. I have 1, 2, 3, 4 points that I care about. Okay, let's write out those 4 points as regular f. I might have to erase f, but that's okay. What do we call that? We call that f. So I have -5, -3. Great. Okay, these are xy values. -5, -3, that gross-looking 3, -3, -1, -1, that's nice. I have 4, 0, that's nice. And then I have, that looks like 6, 4. Now, why did I write this out? Well, I'm going to try to graph its inverse. And really, I want to use these points as a foundation because trying to graph it without the points is just going to be a nightmare for me. Remember, when you have the inverse, you flip-flop the x and the y values. Okay, so now you have -3, -5. Now you have -1, -1, so nothing there changed. Now you have 0, 4, and now you have 4, 6. Okay, so let's graph this out to the best of our ability. -3, -5 is going to live right there. -1, -1 didn't change. 0, 4 lives right there. And 4, 6 lives right there. So, this is not going to look pretty. Nothing I do here ever does. But what you're looking for is a reflection along this y equals x axis, which I kind of see it. I see it. Now, what am I supposed to do here? I want to find where the inverse is greater than the regular f of x. Well, the inverse is green. And it looks like the moment we hit that -1, my green line is above this black line here, which means at this moment, f of x's value, f inverse of x's value, the green line is higher than the f function. So after -1 and all the way to regular 4, because it stops at 4, after -1 to 4 appears to be where my f inverse is bigger than my f. So between -1 and including -1, I guess, maybe not including -1. So I'll keep that as a parentheses. In between -1 and regular 4 is going to be C. Not to be confused with It's Going to Be Me, a song by NSYNC, made famous by Justin Timberlake. Hope this helps. The equation of the function f is given above. I need to find f inverse of x. All right. The way you find the inverse is, first things first, I'm going to call f of x y because it's easier for me to deal with. It's just an ADHD thing for me where if I have f of x instead of y, it's going to look gross and it's going to bother me. Step number 1 is swap your x and your y values. Okay? Swap your x and your y values. So you're now an x equals 2y plus 1 over 4 minus y. Now you solve for your new y. Okay, remember when you have inverses, you flip-flop the x and the y. So in order for me to solve for my new y, I'm going to multiply both sides, and it's going to look kind of sloppy, by 4 minus y, by 4 minus y, and that allows me to cross that out. So distributive property, I have 4x minus yx equals 2y plus 1. Now, if my job is to get y all by itself, we have a bit of an issue here. We have 2 y's. So let's move all of the y's to the one side and everything else to the left, or to the right. So I'm going to subtract 2y from both sides. So that crosses out. Now I have negative 2y minus yx, and then plus 4x is still lingering, equals 1. Now let's subtract 4x from both sides. And now I have negative 2y minus yx equals 1 minus 4x. I still have 2 y's, but oh, if I factor a y out, I now have negative 2 minus x equals 1 minus 4x. Divide both sides by negative 2 minus x. Divide both sides by negative 2 minus x. That crosses out. And you end up with y equals that. Well, I don't want to call it y anymore. I want to call it f inverse. So I'm going to move that over here. F inverse of x is going to equal 1 minus 4x over negative 2 minus x. Now, here's the issue I think I'm going to run into. That double negative on the bottom, they probably don't want that. And looking at what I have here, you might be saying, I don't see any negative x and negative y on the bottom, or negative x and negative 2 on the bottom. So let's do this. Let's multiply the top and the bottom by negative 1. I'm allowed to do that. And when I do that, that flips the sign of everything. So I now have negative 1 plus 4x, positive 2, positive x. And using that information, I should be able to find the guy with the negative 1 and the positive 4x upstairs and the positive 2 and the positive x downstairs, which is that guy, and my answer is D. So even though I did the problem correctly, and it was kind of a mess, I ended up having to do a little bit of math magic to come up with the answer that I wanted. And even though it's written slightly out of order or not in the order that they want, negative 1, positive 4x, positive x, positive 2, D is my guy. Now, if you were allowed to use your calculator here, which you're not, a fun way of making sure that you did this right is graph U and see if you have mirror reflections of each other, which you should, as long as it's over the x equals y axis, like so. It's not going to be pretty, but it'll be fun graph for you to look at. A rocket is launched from ground level and is in flight for 4 seconds. I see it. Its height and feet can be modeled by that equation right there, which is graphed on the figure below. Find an expression H inverse for which the rocket is increasing and determine the domain of its inverse. All right, I got it. In order for you to find the inverse, the first thing I want to do is I want to turn any f of x's, or in this case, h of x's, into y, because that helps me understand the math better. My little ADHD brain can't handle an h of x floating around. So let me rewrite this out. Y equals negative 16 parentheses x minus 2 in parentheses squared plus 64. Second thing that you're going to do is you're going to swap your x and your y values. So y is now x and x is now y. Negative 16 y minus 2 squared plus 64. What you're going to do is you are going to find your new y value. So I'm going to subtract 64 from both sides. So now what that will look like is x minus 64 on the left, I'm kind of being a little lazy here, equals negative 16 times y minus 2 squared. Divide both sides by negative 16. Divide both sides by negative 16. And when you do that, I'm going to be a little clever here. When you divide everything by negative 16, I'm going to actually change this into negative x plus 64 and positive. I'm flipping all the signs because I'm dividing by a negative. I don't think you have to do that, but it looks like I don't see any negative 16s lingering down here, so I'm going to make it positive. So I'm going to make you negative x plus 64 over positive 16. And once again, what I did is by dividing a negative, I can flip-flop everything. That equals y minus 2 in parentheses squared. Now, in order for you to get y all by itself, we need to square root both sides. When you square root both sides, you usually have a positive or a negative, right? But in this case, they only want the positive part. And that is the only part that's going to make sense. So a positive square root when graphed looks like this. A negative square root when graphed looks like this. Obviously, I don't want stuff going underground. I want stuff going above ground. So I am going to get rid of you. And I'm only going to keep the positive part. So I really don't need that sign there anymore. What that does is I now have the big square root of negative x plus 64 over 16 equals, these guys cancel out, y minus 2. Add 2 to both sides. Let's see how they want me to write it. I have square root of negative x plus 64 over 16 plus 2 equals y. Let's flip-flop it and turn that into h inverse equals square root negative x plus 64 over 16 plus 2. Now this is my height. Okay. By doing it this way, I get this picture right here. And of course, that's obviously not drawn to scale because these go by 2s and these go by 10s and stuff like that. So it's not drawn to scale at all. But by doing this, I am now flip-flopping what my y, x, and x-axis stand for. The x-axis now stands for height. When I shoot a rocket up in the air, I really hope it doesn't go 2 feet in the air. I'm expecting it to go 64. So now that my x and my y are swapped, my new domain would be way the heck over here and would be 64. So B is my answer. So a lot to do there. There was a lot there. Not only did we have to find the inverse, we had to make sure it was positive only, and then we had to make sure that we had the right domain. But we did it, and I'm proud of each and every one of you. Given that b is greater than 0 and b is not 1, okay, write the equation below in its equivalent logarithmic form. All right, well, an equation in its equivalent logarithmic form has you take something in the form b of x equals y and changes it to log base b of y equals x. So this looks like this, and I need to make it look like that. So my x is 4, my y is 8, and my b is b. Makes sense? So I'm going to change this into log base b is base b of y is now 8 equals x, which is now 4. And you're my guy. Write the equation below in its equivalent exponential form. All right, well, exponential form looks like this. B to the x equals y. I could take something that looks like b to the x equals y and rewrite that as log base b of y equals x. So I'm given the log form. What I don't see here is I don't see a base. And when I don't see a base, it's invisible 10. So my base is invisible 10. My y is that c right there. And my 14 is going to be x. So now when I take this guy and make it look like u, I could say my base, which was invisible 10, to the 14th power is going to equal c, which is u. So 10 times 10 times 10 a bunch of times. 1 with 14 zeros attached. That's like my bank account. Hopefully after you guys keep watching these videos, that'll be true. That actually won't be true. That's a lot of money. Like and subscribe, though, please. Which of the following expressions is equivalent to 3? All right, so I have a bunch of them. So let me remind myself that log base b of y equals x can be written as b to the x equals y. So although this is an unnecessary step, okay, this is log, this is log, this is log, this is log, I like to set all of these equal to x and then rewrite them. Might be doing too much here, but this is just what I like to do because it helps my brain navigate these. So you are a base, you are my y, and you're my x. So 5 to the x equals 15. That's how I can write you out. You're an invisible 10. So 10 to the x equals 3,000. 8 to the x equals 2. And 4 to the x equals 64. One of these guys has to be 3, so x is 3. 5 to the third is 15? Nope, 5 to the third is like 100 something. X to the third is 3,000? Nope. 10 to the third, rather. 10 to the third is 3,000? Nope. 10 to the third is 1,000. 8 to the third is 64. No, it's not. It's like, no. But 4 to the third is 64. Ugh. Well, I botched that up with my words, but you know what? I still got the end result. 4 to the third is 64. That's my guy right there. If log base 2 of 1 over 8 is x, then x is equal to, All right, well, I know that log base b of y equals x can be written as b to the x equals y. So if you're my base and if you're my y and x is my x, I can write this out as b2 to the x equals 1/8. I don't see a calculator there. Ooh, I know what I can do. I know that I can write this out as 2 to the x equals 1 over 2 to the third because 8 is 2 to the third. And since this is on the bottom of a fraction, I can move you upstairs and make the exponent negative. So now that I have a base of 2 to the stuffed power equals a base of 2 to the stuffed power. And when you have the same exact bases equal to each other, their exponents equal to each other. So x in this case is -3. Oh, wasn't that fun? Find the value of b such that log base 4 of log base 3 of log base 2 of b is 0. Holy cow. Well, this is what I'm going to do, and I don't know if this is the best way to do it, but I'm going to do it anyway. There's a little trick that's like, let's simplify this. If I were to give you something like this, just the log base 2 of b equals 0. And if you want to simplify this, you could take 2 to the of both sides. And by taking 2 to the of both sides, the 2 to the log base 2 cancels out, and you drop down the b, and in this case, 2 to the 0th power is 1. So what I'm going to do is I'm going to work from the outside in and do that 3 times. All right? So the first thing that I'm going to do is I'm going to 4 to the both sides. 4 to the log base 4 cancels these guys out, and now you could drop down log base 3 of log base 2 of b equals 4 to the 0th, which is 1. Let's do it again, but with 3 to the. 3 to the both sides cancels out the 3 in the log base 3, dropping down log base 2 of b equals 3 to the first power, which is 3. One more step. If I 2 to the both sides, log base 2, or 2 to the log base 2 of b cancels out those guys, and I'm left with b equals 2 to the third power. 2 times 2 times 2 is 8. What a weird problem. I liked it, though. Find the difference. Log base 16 of 32 minus log base 32 of 16. No calculator, so I have to do this the old-fashioned way. I know that a log written in log base b of y equals x can be rewritten as b to the x equals y. So this is what I'm going to do. I'm going to make u look like u, and then do the same thing here, but be a little bit lazy about it. So let's focus on just the left side, and then I'll kind of use that as a shortcut to find the right side. U would be my base. U would be my y. So I'm going to make sure that I have just some random x that it equals. So x equals that part. So I can now write this out as 16 to the x equals 32. Well, I don't know 16 to the what power equals 32 because it's not 16 to the first, it's not 16 squared. But you know what I can do? I can rewrite this guy as 2 to the 4th power to the x. Similarly, I can write that as 2 to the 5th power. Okay, so 2 to the 4th to the x means I multiply exponents, and now I have 2 to the 4x equals 2 to the 5th. Now that I have the same base and they equal each other, these guys equal each other. So 4x equals 5, divide by 4, divide by 4, and x equals 5/4, which means this guy, when evaluated, log base 16 of 32 is the same as 5/4. Now, there's a bit of a shortcut, but this is how I'm going to handle this one. Okay, I'm going to handle this one. I'm going to do the same thing, but now I have 32 to the x equals 16. I'm doing the same thing, but now these guys are switched, which means these guys are switched. And you might be thinking, does that mean these guys are going to be switched? Just wait. This is the same as 2 to the 5th. So 2 to the 5th to the x is the same as 2 to the 4th. That's supposed to be a 2. So 2 to the 5x equals 2 to the 4th, means these guys are equal to each other. So 5x equals 4, divide by 5, divide by 5. And yeah, I should have just listened to my heart. Should have just listened to my heart. X equals 4 over 5, which means u evaluate to 4 over 5. So u minus u. Now, these guys don't subtract because they're different denominators. So multiply this guy by 5 over 5. Multiply this guy by 4 over 4. That way we have 20 in the denominator. You get 25 over 20 minus 16 over 20, which simplifies to 9 over 20. Wacky problem, but we did it. The pH of a substance can be calculated by the formula above. pH equals negative log no base x, where x represents the concentration of hydrogen atoms of the substance in moles per liter. Nifty. If lemon juice has a pH of 2.27, determine the pH of an acid with 2 times the hydrogen ion concentration as lemon juice. Thank you, Lord, we have one of these guys. So let me do two things. My pH is 2.27, so let me rewrite this equation. Instead of pH, I'm going to do 2.27. That's going to equal negative log. Now, since there's no base, I'm going to write out the fact that we have an invisible base 10 and then of x. What I want to do is I want to write that out in exponential form. So the way you write something down in exponential form is if I give you log base b of y equals x, you can write that out as b to the x equals y. Okay, so I'm going to rewrite, well, first off, let's do this. That negative is bothering me. Let's multiply both sides by negative. Negative 2.27 equals regular log base 10 of x. Using this formula, I can rewrite this out as 10 to the negative 0.27, negative 2.27 equals x. Now, this is how I'm going to finish up this problem. I need to throw that into my calculator and get x equals stuff. Okay. What that does is that gives me the ion concentration of hydrogen atoms and blah, 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 blah. Okay, of that pH. What I want to do is I want to take that. I want to double it and then find the pH of that. So all in my calculator, what you're going to see me do is you're going to see me type this guy out. You're going to then see me multiply it by 2 and then throw it back into this formula up here to get a number. All right, so let's run to the calculator and see what happens when I do that. All right, this is going to be a gross one. You ready? So first thing we need to do is we need to do 10 to the, which is that guy right there, negative 2.27. We need to double that, so times 2. And now that I have that, I'm going to throw it back into that original equation that hopefully you see right there on the right side. So negative log base 10 is negative log. And rather than me typing that whole thing out, a little trick that I could use is I can hit second negative symbol, and it lets me plug in the answer that I just got, hit enter, and I get 1.96 blah, 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 which seems to match up with C. So let me show you what that looks like back on the problem. We'll be done. All right, so in this case, x equals 0.00537 blah, 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 blah. I took that and I multiplied that by 2 to give me 2 times the hydrogen atom concentration. And that gave me the number 0.01074, blah, 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 blah. Okay. So an acid with 2 times that has this, and I need to find the original pH of that. So what I did is I said pH equals, and I typed out negative log regular base 10 of 0.01074, blah, 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 blah. I got 1.96897, blah, 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 which ended up being C. So very unique and challenging problem, pretty difficult stuff. Which equation matches the graph shown above? I'm going to do this in a very unique way. First things first, though, I know that this is a log because logs look like that. So adios and adios. Now, the way I can figure out which one C and D is you can do some memorization, but I'm going to go about this in a very unique way. I have like a base of 3, I have a base of 2, and I want to see which is which by comparing this to its inverse counterpart. Okay, so its inverse means if I were to graph it, you just flip the x and the y values. So this right here is the 0.10. Let's graph the 0.01. This is the 0.23. Let's graph the 0.32. This is the 0.46. Let's graph the 0.64. And this is the point that looks like 8, 9. So let's graph 9, 8. I'm going to try to attempt to draw this the best that I can. Usually I'm awful at this, but if I do like the little, sketchy way, actually didn't turn out half bad at all. Now, this is what I'm looking at. When I want to write this out as an exponential function in the form y equals a times b to the x, what I have is I start out with an initial value of 1. So that A, kind of useless, don't need it, let's get rid of it. Now what's really important is B tells you what you multiply every time. Okay, I go up 1, and then I go up 1, 2, and then I go up 1, 2, 3, 4. B acts as a common ratio. So what I get here is my base, whatever that is going to be 2. Because I multiplied, I went up 1, and I went up 2, and then I went up to 4. And so my base is 2, which means if I compare it back to the original version, D is going to be my answer. And you might be thinking, well, then what's that 3 stand for, sir? Well, notice up here, in the inverse, I went up 1 over 1, 2, 3. I went up 2 over 1, 2, 3. I went up 4 over 1, 2, 3. So when I erase this and go back to the original problem, when I was in exponential form, that base told you how many spaces I go up every time. Well, now it tells me how I go over every time. So when the base is 2, I go right 1, and then I go right 2, and then I go right 1, 2, 3, 4, and then the next one would be right 1, 2, 3, 4, 5, 6, 7, 8. And you might be thinking, all right, well, how much do you go up then? Well, notice this was right 1, up 1, 2, 3. Right 1, 2, up 1, 2, 3. Right 1, 2, 3, 4, up 1, 2, 3. So my next guy, if I needed another dot, I'd go right 8, up 3. Then right 16, up 3. Don't need to go that far. But what I learned by doing this is basically your number in front of log acts as almost like a rise for your slope. Okay. And then your 2, your base in this case, tells you how many times we're going to multiply to move over to the right next time. So I went over 1 times 2, right over 2, times 2, right over 4, then over 8, then over 16. Kind of interesting. I never looked at logs that way, but you learn something new every day with the math teacher. Go like and subscribe. The pH of a substance is a measure of the acidity of a substance on a scale from 0 to 14 grade. The pH of a substance is calculated by that familiar looking formula, pH equals negative log X, where X is the hydrogen ion concentration of a substance in moles per liter. Which of the following best describes the relationship between the hydrogen ion concentration of a substance and the pH of a substance? All right. A substance with a pH of 4 has 10 times the hydrogen ion concentration of a substance with a pH of 3. I don't know. A substance with a pH of 4 has 1/10 the hydrogen ion concentration as a substance with a pH of... So basically what I really need to do is I need to turn this into, like, it wants me to find 10 times. I need to turn this into its exponential counterpart. So pH equals negative log invisible base 10 of X. And what I'm going to do is I'm going to multiply both sides, so now it looks like this. I'm going to multiply both sides by -1, so now I have that. I'm going to turn that into its exponential friend. So what that looks like is 10 to the negative pH is going to equal X. And X stood for the ion concentration, or the hydrogen ion concentration, the hic for all of you people who live down south. Sorry if I offended you. A substance with a pH of 4 has 10 times the hydrogen ion concentration. All right, so if the pH is 4, all right, that means if the pH is 4, that's 10 to the negative 4th. 10 to the negative 4th is the same as 1 over 10 to the 4th, which is 1 over 10,000. 1, 2, 3. Okay, pretty small. If it has a hydrogen concentration of 3, or a pH of 3 rather, having it backwards, pH of 3 means I'm going to have 10 to the negative 3rd, which is 1 over 10 to the regular 3rd, which is 1 over 1,000. This purple one is 10 times more than the green one. Is that what they wanted? So the 3 is 10 times more than the 4. They said the 4 is 10 times more than the 3. No. The substance with the pH of 4 is 1/10. Yep. The 4th is 1/10, because if I were to multiply U by 1/10, that works because it's smaller. That's smaller. So it's B. Has nothing to do with adding more to it or subtracting 10 to it. It has to do with taking 1/10 of it. Very interesting problem. Didn't like it at all. Not at all. Hated it, actually. Hated it a lot. Which of the following functions has the following graph on the domain negative infinity less than x is less than infinity? All right, so it looks like what I do here is I ended up doing some stuff that just kind of cancels each other out. E to the log x does nothing for me, but e to the ln of x has that e and that ln cancel each other out. I don't want to completely get rid of it, though, because I have a feeling that's not going to be the only one that cancels out. But that does become x. 10 to the log base invisible 10 of x does become 10, because 10 to the log base 10 cancels out, so that goes to x. And log base invisible 10 of x also does that. So all three of you are x. Here's the problem. This right here tells me I'm allowed to plug in negatives. Am I allowed to plug in a negative for you? No, because ln of a negative number doesn't exist, so it can't be b. Am I allowed to plug in a negative for you? No, because a log of a negative doesn't exist, so it can't be c. Am I allowed to plug in a negative for you? Yeah, but wait a minute. If I plug a negative in, won't I get a negative? Nope. If you plug in negative 1,000,000, you would just get 10 to the negative 1,000,000, which is 1 over 10 to the 1,000,000th. That's a really small decimal, boys and girls. The answer is D. Very strange problem. But again, what we did is we simplified, and I asked myself, which of these am I allowed to plug in negatives? And that's the only guy where I'm allowed to plug in a negative, because it just turns it into a fraction and doesn't make it negative itself. Fun, 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 fun. Select values of f of x are shown in this table above. If the f inverse is g of x, which of the following expressions are equivalent to f of x? All right, well, let's do this. Let's make a table for g of x. If g of x is the inverse, we know that all I have to do is just swap them. Swap them. Swap them good. Which of the following expressions are equivalent to 4? So I need to plug in all of these guys and see which one gets 4. So f of g of 4. First off, g of 4 means I'm going to go over here and let me do this. Let me split this up. Let me put this in red over here. F of g of 4 means, let's find out g of 4, which is 2. So f of g of 4 means f of 2, and f of 2 is 4. Check. Let me do this in blue. F of 2 is going to be 4. I already knew that. Plus g of 2 is going to be 1. You're 5. I wanted 4. Sorry. F of 2, I kind of know what's going to happen, is 4 minus g of 2 is 1. That's not 4. That's 3. So not you. So the only guy that seems to work is just 1. Oh, inverses, you get me every time. F of x is an exponential function and g of x is its inverse. If f of 4 equals 25 and g of 19 is 11, what is the value of g of 5? All right, well, g is the inverse, right? So f of 4, okay, here's x, here's f of x. F of 4 is 25. Remember with the inverse, whatever point you get, you swap them, which means if g of 19 equals 11, that means f of 11 equals 19. 11, 19. Now, f of x is exponential, which means g of x, its inverse is logarithmic. So this is what I have to do. I have to go over here, and I have to go to my calculator, because I'm allowed to use one, and I'm going to do the ln reg. I'm going to get a gross terrible equation, but I'm going to use that equation to plug in 5 and see what happens when I plug in 5. Let's take a look. All right, so I have to ln reg this guy. What I'm actually going to do is, I know in the chart that I had on the paper or on the slide or whatever you want to call it, I had just a regular function f of x. What I want to do is I want to plug in my values for the inverse and ln reg that. So I'm going to make sure when I plug these in, I plug in the reverse of them. So 25 gets matched up with 4. Okay, if I were to use 425, I would get an exponential. I want to do logarithmic with this one. I'm going to do 19. Gets matched up with 11. Bada bing. Now I'm going to use ln reg. So I'm going to go to stat, calc, and ln reg is right there at 9. There you are. ln reg for natural log. Backwards. Now I'm going to use this equation. So I'm going to go to store regression equation, hit vars, go right to y vars, and go to function and y sub 1. Now when I hit calculate, I'm going to be like, gross, I don't want to write that out. Perfect. I don't have to. Because what I have to do is I have it right there. Boom. Sorry. Boom. Gross. And if I go to table, I care about what happens when g is 5. So where's g5? Right there. And what do you get? 45.0515773. So I'm going to write all that out and going to be done. So I didn't even bother writing that equation down because I don't really need to know it. But what I do know is when I plugged in 5, I got 45.0515773, blah, 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 logs. Fun. A logarithmic function, f of x equals 2 log No base. I wonder what that means. H plus or x plus h plus k has that limit where f of x is going to hit negative infinity as you approach -3 from the right. Oh, it also passes through the point -2, 4. I have a calculator here. I don't think I'm going to use it. In fact, I'm not going to. So even though it's a calculator, I'm not going to worry about it. This is what I know. Whenever I have to deal with graphing logs and it looks like that, I'm going to compare it to its actual form, f of x equals a log base b of x plus h plus k. It's actually x minus h. Pardon me, pardon me, pardon me, me. Pardon me, pardon me, me. That does change things here. Now, what do I have? A is 2, and that gives me a vertical stretch here. Not really going to affect based off of the two numbers that I see here. We'll get to that in a second. Okay, log base b, again, not going to really affect anything. Log base 10, not going to affect anything. Don't worry about it. This is what I have to worry about, this statement right here. Okay, if the limit as x approaches -3 from the right is my infinity, and this guy is positive, that tells me when graphed, I'm going to have a vertical asymptote at -3 because this picture is going to go like that. So again, I'm coming from the right to -3 and hitting negative infinity. So that's my guy right there. Whenever I have a vertical asymptote, I know that my vertical asymptote equation is x equals h, which means h is -3. So part 1, we're done. H is -3. Now, k is always going to be where your point is 1 unit to the right of the asymptote. It just so happens that -2 and -3 are 1 unit away from each other. And since -2 is 1 unit to the right of -3, that tells me that k is 4. So if I were to write out this equation in full, and maybe this is where the calculator would come in handy, even though I'm not going to use it, I would graph 2 log base 10. And remember, the regular log in your calculator is log base 10. So you can just plug this straight into your calculator. Of x, what did I say h was? -3. So x, in this case, if h is -3, this is going to be +3. Plus k. K is going to be 4. I would plug this right into my calculator and make sure that it goes through the point -2, 4. Now, I made a little tiny mistake here. I'm going to cross that out because they're giving me this version of the formula, which I don't like. I'm not used to that. I'm used to this version of the formula that I created. So in my case, we are going to say that the h that they want is going to be +3. So that's kind of annoying. And the k that they want is still going to be 4. But again, the reason why the calculator here might be useful is if you were to graph this guy right here into a graphing calculator and see and double check like your table, because it would go through -2, 4. Just make sure it goes through -2, 4 on your table, and you'll be in good shape. Find all relevant information from the given function, sketch the graph. Now, I have f of x equals ln of x plus 8 in parentheses plus 3. Now, those of you who watch all of my videos, you know very well that if I'm graphing something that is a log, and yes, this is a log because ln is log base e, I'm going to compare it to f of x equals a, which gives me a vertical stretch or compression, times log base b, which is my base, but also deals with a horizontal stretch or dilation, or shrink, or whatever you want to call it, x minus h plus k. H determines left or right movement, k determines up or down movement. You make things look steeper, skinnier, whatever. You move, left to right. You make things shorter, okay, so to speak. Now, this is very important. I care about if A is positive, and it is. It's invisible 1. And when that happens, you get a graph that looks something like this. Now, a couple things are happening here before I can really answer these questions and feel happy about it. One thing I have is I have a vertical asymptote. Now, vertical asymptote exists at places where you're not allowed to plug in specific numbers. Now, I'm not allowed to plug in anything that would make this parentheses negative or 0. Why? Because you're not allowed to take the ln or a log of a negative number or of a 0 number. So if I were to plug in negative 8, I would have ln of 0. That's not allowed. Anything bigger than negative 8 is okay. Now, it just so happens that h is negative 8 in this case. H is negative 8. My vertical asymptote is found at the equation x equals negative 8. So asymptote is x equals negative 8. Anything smaller than negative 8, not allowed to plug in. Anything bigger than negative 8, I'm gold. Now what that means is I'm not allowed to plug in anything that is negative 8 or smaller than that. So my domain is found by doing essentially h to infinity. That's my domain. So in this case, my domain is going to be negative 8, okay, not including negative 8 because you're not allowed to take the ln of 0, to infinity, to infinity. Here, we'll turn that 0 into double 0. Look at that. Perfect. Nailed it. Now, if you're looking at this and saying, we move this up 3, how does that affect my range? It doesn't. No matter what, this is going to continue going downward, and this is going to continue going up and to the right no matter what. So my range is always going to be, in this case, everything. And as long as a is positive, my range is always going to be infinity, the negative version, to regular infinity. Always, always, always. Now, this is where it gets weird. Okay, my end behavior. Usually when you think end behavior, you think, all right, ln as x approaches x to the negative infinity. But we can't. We're not allowed to go to the negative infinity. The furthest I can go moving to the left is to negative 8. So what I will say is the limit as x approaches negative 8 from the right side. Okay, negative 8. Of course, 8 and infinity are similar looking things, so, that's supposed to look like that. From the right side of f of x. As I move to negative 8, I hit a brick wall. But right before I hit that brick wall, I'm going down to negative infinity, so that's the left side of my end behavior. The right side of my end behavior is I'm allowed to go all the way to the right, and as I keep moving to the right, I also keep moving up. So the limit as x approaches positive infinity of f of x is going to equal infinity. Now let's take that picture and make it look a little bit better. Okay, this is the worst part of all of this. No calculator allowed, no calculator needed. We'll be all right. First thing that happens is I know that I have a horizontal or a vertical asymptote at negative 8. Now, there's a little rule that says whatever this number is, okay, that is going to be your y value, 1 unit to the right of your vertical asymptote. So if this was 3 and if this was negative 7, I have a point right there. And that's basically how I'm going to wrap this problem up, because as I move to the right, I am now dealing with a horizontal stretch involving E, and I really can't label stuff without calling things E, and I'm not about to do that. So I'm just going to draw this guy right here. It's going to keep going up and to the right. Okay, not the prettiest picture ever, but we accomplished everything we needed to accomplish. And again, that point right there is negative 7, negative 3. Not the prettiest problem ever, but we did it. Let x and y be positive constants. Which of the following is equivalent to 5 log x plus 6 log y? We have 2 log rules going on. First things first, if you have a number in front of a log, you're allowed to take that number and make it the exponent of the stuff inside the log. In other words, 5 log x is the same as log of x to the 5th. What's my base? I don't know, 10. I don't have one. Plus 6 log y is now log of y to the 6th. There's another rule that says if you have the same base, and again, we're going to pretend that these 10s are there. Even though they are 10s, we're just going to pretend that we can see them. If you add logs of the same base, multiply the insides. So what this becomes is, since we're adding log base 10 of x to the 5th and log base 10 of y to the 6th, I get log base 10 of x to the 5th, log to the 6th. Again, that 10 is not necessary. I just keep writing it down because it helps me visualize things a little bit better. I get B in this case. Pretty easy. Let x and y be positive constants. Which of the following is not equivalent to log base 3 of x plus 3 plus 2 log base 3 of x minus 1 minus log base 3 of x plus 2? All of these have the same base, which means they combine. Now, you always want to combine things that are adding first. When adding 2 logs of this, oh, I didn't even notice that. This has a 2 living out in front. I take it back. This is the first thing you want to do. If you have a coefficient attached to a log, you're allowed to take that number and set it as the exponent to the stuff inside the log. So that middle guy becomes log base 3 of x minus 1 squared. Log base 3 of x plus 3 doesn't change, so we'll write that out. X plus 3, that's still there. Minus log base 3 of x plus 2 is still there. Now we can deal with these Christmas guys that are combining through addition. When you add 2 logs of the same base, you multiply the insides. So this guy becomes log base 3, and let me add these brackets, of x plus 3, x minus 1 squared. And then on top of that, we're subtracting log base 3 of x plus 2. Always take care of the addition stuff first. Now what we have is we have the subtraction guy that's just lingering out. When you subtract 2 logs of the same base, you divide the insides. So this whole thing is now going to become log base 3 of that guy, x plus 3 times the quantity x minus 1 squared, all over that guy, x plus 2. Now to find out which one of these is not this. Well, we have our answer already. It's A. In none of these, like, I'm looking at these and you're saying, okay, I see what they want. This guy is a mirror image. These guys are exactly the same. I can rewrite out x minus 1 squared as x minus 1 times x minus 1. So B is good. C is the same. And if you look at D, you see the x plus 3. And if you're thinking, oh, wait a minute, x minus 1 times itself, x minus 1, foils out to x minus 2x plus 1, this is eventually the same. In none of these cases do I have a coefficient of 2 lingering out here. So A is going to be my answer because A is the guy that's not the same. Isn't that fun? Logs. When I teach logarithms, I'm always just like, have fun with it. Blink-182. But in this case, I am teaching logarithms, and you have to have fun with it because they're not a lot of fun. Maybe manipulating them, but the graphing aspect, I hate it. So this is what I do. Whenever I have to deal with graphing, domain, range, shifting, whatever, I always compare whatever log I have to this guy right here. F of x equals A log base B of x minus h plus k. Very kind of like a vertex form, but with logs. A gives you a vertical stretch or shrink. We're not going to see that here. I mean, we are going to see it, but it's not going to matter with what I'm being asked. Same thing with B, which gives you a horizontal stretch or shrink. Don't really care that much. Okay, this is what I care about. H tells me whether I move left or right. It's all backwardsy, but if I have something like x plus 3, I actually shift left 3. If I have x minus 3, I shift right 3. K is similar, but, normal, where if that's plus 3, I go up 3, and if it's minus 3, I go down 3. Now, why is all that important here? And what's really important is the fact that you are a positive number. If a is positive, a log is going to be graphed like this. Now, as you see, what happens on the left here is there's like a brick wall that this guy hits. All right, this is a vertical asymptote. That vertical asymptote says you're not allowed to plug in any numbers over here on this side. Why is that? Well, log, you're not allowed to take the log of a negative or a 0. So at some point, x, or whatever this parentheses is, has to be positive. So what that means is if I gave you a number with x, your domain would be h to infinity. Don't include h to infinity, okay? Because this is your brick wall and you're allowed to go all the way to the right. Similarly, your range is what you're allowed to get from the bottom to the top. Now you might be thinking, +2, that means you move up 2. That's going to change your range, right? Nope. No matter what, this guy is always going to continue going downward, no matter whether you shift it up 2 or down 2,000, it's always going to go down forever, and this guy is always going to go up and to the right. So your range, as long as you're a positive number, is always going to be negative infinity to positive infinity. So what do I have here? Well, since there's no number included with x in this case, I have an invisible 0, which tells me I have a vertical asymptote at x equals 0, or h happens to be 0. So my domain for this problem is 0, but not including 0. You're not allowed to plug in 0 because you're not allowed to take the log of a 0. It's against the rules. To infinity. My range is going to be negative infinity to infinity. So I did a little extra, a little more than necessary to kind of get to this point, which probably could have taken me about 30 seconds. I just struggle with the graphical side of logs, and if I do it and I'm a math teacher by trade, I'm sure there are people out there who kind of struggle too. So hopefully this helps. Like and subscribe. If log of 3 equals x and log of 4 equals y, which of the following expresses log base square root of 12? All right, well, I don't know what log of 3 is x means. I don't know what log of 4 of y means, but what I can do is I can rewrite this into its other form. So I can write this out. Remember, if you have no base at all, it's invisible base 10, invisible base 10, invisible base 10. Will that really help me? I don't know, probably not. But what I can do is I can rewrite this out as 10 to the x equals 3, and I can write this out as 10 to the y equals 4. Now, why am I doing that? Because it isolates 3 and it isolates 4 and now gives me 3 and 4 on its own thing. So now I can kind of plug it into here and see what happens. I want to find out what log base 10 of the square root of 12 is. So first things first, let me rewrite this. Log base 10 of the square root means stuff to the 1/2. Now 12 just so happens to be 3 times 4. 3 times 4. So log base 10 of 3 times 4, wait a minute, 3 is 10 to the x. So why don't I replace 3 with 10 to the x times, and wait a minute, 4 is 10 to the y. So why don't I replace u with 10 to the y? And now I close the parentheses and I take it to the 1/2 power. Now I'm kind of getting where I want to go, but this log is still in the way. However, I know there's a rule that says log base 10 of 10 to the stuff means things will go away. So I need to make these 10s go away. How can I do that? Well, 10 to the x times 10 to the y means I'm multiplying things of the same base, so I can add exponents. So let me write this out as log base 10 to the x plus y. Again, if you got lost with what I did there, when multiplying terms of the same base, add the exponents. To the 1/2 is still there. Now I still have that 1/2 there. But if I have an exponent taken to an exponent, multiply the exponents. So one last step before I can start crossing things out is I can write this out as 10 to the x plus y times a half, or a half times x plus y. Log base 10 of 10 to the stuff crosses those out, and you're left with just the stuff. And it just so happens that the stuff is 1/2 x plus y, which is d. Tricky, tricky, tricky. Approximate log base b of 18, given that log base b of 2 is whatever, and log base b of 3 is whatever. It's a calculator problem. Okay, so let me think what I can do. I can try to think of maybe some kind of like ln reg or logarithmic regression, but I have another idea. Let's pretend that I'm not allowed to use the calculator. Let's just make believe I'm not allowed to use the calculator. What I notice is that all of these guys have the same base, right? So if I wanted to, I can basically rip this apart and say log base b of 18 is pretty much the same as, can I make 18 the same as, wait a minute, 2 times 3 times 3 again is 18. So this is a true statement. 2 times 3 times 3. That's a true statement. Wait a minute. When I multiply stuff inside of a log, I can expand that using addition. In other words, if I were to give you something like log base b of 2 plus log base b of 3, I would get log base b of 2 times 3. So working backwards, I can write this out as log base b of 2 plus log base b of 3 plus log base b of 3. Now, normally we're used to doing something that looks like this and getting to something that looks like this, but now we're working backwards. So is this kind of a weird problem? Like, would everybody know that I'm supposed to turn this into this? No, but that's why we do these problems. Just so happens that we know log base b of 2 is that guy right there, 0.4307, plus log base b of 3 is 0.6827, plus log base b, again, 0.6827. So the only reason why I would need my calculator is to do this calculation right here. But let's just say I can do this in my head. This ends up being 1.7961. So yeah, let's just make believe we used a calculator. And we end up with D. Very unique problem. You have to think outside the box with this one. Solve the equation log base 3 of x minus 8 equals 3 for x. Now, whenever I'm solving and I have x inside of a log or an ln, I want to write it out into its other form, but I'm going to be a little clever, be a little creative here. Okay, I'm just going to rewrite the equation. I want to get rid of that log base 3. How can I get rid of a log base 3? By taking 3 to the of both sides. Now, I know that's bad grammar, but that's how I remember it. Take 3 to the of both sides, and that allows these guys to cancel out, and you could drop down an x minus 8. 3 to the third is 27. Add 8 to both sides. Add 8 to both sides. X is going to equal 35. Now, before you just circle it and call it a day, make sure always, if you're solving a log, you're allowed to plug that number in. In other words, if I were to go up here and plug this number in and get log of a 0 or log of a negative, you can't do it. But I am allowed to do this because log of 35 minus 8 is log of a positive number. This is allowed. That is our guy. Did I need you, Mr. Calculator? No, get out of here. What are all the values for x for which log base 3 of x minus 8 is less than or equal to 3? All right. First things first. I am not allowed to plug in specific numbers. And I know that whatever this is, if I have a log base b of x minus h, whatever h is, becomes my vertical asymptote. So I am not allowed to plug in anything that is 8 or below. If I plug in 8, I'm not even allowed to plug in 8. So my domain here, that's supposed to be an m, my domain is going to be 8 to infinity, not including 8. If I were to plug in 7, this would be 7 minus 8 is -1. You're not allowed to do that. So that's the first thing that I need to keep in mind. I have a domain restriction right there. I'm going to keep that off to the side. Okay, now this is what I'm going to do. I care about when x is living inside the log, and I need to find when x is living inside the log. I hate the way that looks. So let me rewrite this out. Log base 3 of x minus 8 is less than or equal to 3. I want to get rid of that log so I can have x no longer living inside of a log. So what I'm going to do is I'm going to take the 3 to the of both sides. 3 to the log base 3 cancels out. X minus 8 drops down. That's going to be less than or equal to 3 to the third, which is 27. If I add 8, and if I add 8, cross u out, I end up with x is less than or equal to 35. So if my domain says that 8 is the smallest number that I'm allowed to plug in, and this guy here says that 35, including 35, is the largest number that I can plug in, then my x values are going to be everything in between 8, not including 8, and 35, but including 35. So no calculator needed on this one. Bye. Consider the functions f and g given by f of x equals log x minus 1 and g of x equals log x minus 1 plus log x minus 2. All right, so two different guys that are kind of similar. In the xy plane, what are the x coordinates of the points of the intersection of the graphs f and g? Oh, basically, you just set these guys equal to each other and solve. I can handle this. Log invisible base 10 x minus 1 equals log invisible base 10 of x minus 1 again. How about that? Plus log base 10 of x minus 2. Now, what I don't want to do is eliminate these and lose x values. So this is what I'm going to do instead. I have two logs on the right side of the same base that are being added together. When you add two logs of the same base, multiply the inside. So the left side is still going to be log in base 10, invisible 10, is going to equal, multiply these guys together, which means they FOIL x squared, so log x squared minus 2x minus 1x, so minus 3x plus 2. There you go. Now, x is living inside a log. That's always problematic. So why don't I take 10 to the of both sides and make all of those logs go away? Since this is invisible base 10, you disappear, and I drop down x minus 1 equals x squared minus 3x plus 2. I'm going to subtract x. I'm going to subtract x. I'm going to add 1. I'm going to add 1. That gives me 0 on the left, and now I have something that's factorable, and I'm going to use the zero product property, something that you've seen a million times. What is that, plus 1? Gross plus 1. 0 equals parentheses x, what is that, minus 3x minus 1. The zero product property says that my x values that I get by doing this are going to be positive 3 and positive 1. But before I circle that, wait a minute. I'm not allowed to plug in one of these numbers. If I were to plug in 1 into either u, or u, I would get something that's undefined, because this would be log of 0, which is impossible, or log of 0, which is impossible, or log of -1, which is impossible. So 1 is not an option. Can I plug in 3? Yep, because you get 2, you get 1. So I can plug in 3. So whenever you're solving for a log problem and you see two potential answers, always check. Because usually if that's the case, One of them's not supposed to work. And in this case, that one of them was 1. What are all values of x for which log base 2 of x minus 4 plus log base 2 of x plus 3 equals 3? All right, whenever I see these log problems and I have x floating around in the log, that means I have to get rid of the logs. So that's what I'm going to do. First things first, though, I see that I have a log base 2 being added to a log base 2. I can multiply the insides. So if I multiply the insides, it's actually a FOIL problem because you're multiplying x minus 4 times x plus 3. So it's a FOIL problem. X times x is x squared. Plus 3x minus 4x is minus x. And then minus 12. That's going to equal 3. Now I have to get rid of that log. It's a log base 2. So what I can do is I could take 2 to the of both sides. So 2 to the log base 2 cancels out and you're left with just x squared minus x minus 12. 2 to the third is 8. If I subtract 8 from both sides, I now have a very familiar looking zero product property problem. X squared minus x minus 20 equals 0. Does this factor out? Can I come up with two numbers that add up to -1 and multiply out to -20? Yup. How about x minus 5 and x plus 4? That equals 0. And according to the zero product property, x is going to be 5 and -4. Oh, but beware. Whenever you're solving a log problem and you're trying to find the x living inside a log, check your answers to make sure if your answers make sense. What I mean is, can I plug in 5? 5 minus 4 gives me a 1. All right. 5 plus 3 gives me an 8. Fine. What's the issue? Can I plug in -4? -4 minus 4 is -8. I can't take the log of a negative number, so -4 isn't allowed. So there's always a trick whenever you're doing these log problems and you end up with more than one answer. More often than not, you're not allowed to have more than one answer. Check your answers and make sure that only one of them works, because only one of them in this case will work, and that guy is 5. What is the value of x in the equation above? All right, I have myself a calculator here, so I'm hoping things that are magical are going to happen, but probably not. I have to isolate this x somehow, which means the first thing I'm going to do is get rid of that 4. Now, nothing magical happens, right? Like, a nice thing would be like if this number became like 27 or 9, so I could do like, 3 to the 3x equals like 3 squared, but that doesn't happen. I have 3 to the 3x equals 5, so that's no good. So now what I have to do is I have to write this in its logarithmic form. You are my base, so I have log base 3 of 5 equals 3x. So what I'm going to do is I'm going to run in my calculator. But before I even do that, oh no, my calculator's log is a base of 3. Which is the value of x, or what is the value of x in the equation above? All right, 3 to the 3x plus 4 equals 9. So let's get rid of 4 and hope magic happens. Well, it doesn't. This is what I meant by magic. Oh, wouldn't it be nice if this was like, 27 or 9, so that I can be like 3 to the 3x equals 3 squared, or 3 to the 3x equals 3 to the anything. That doesn't happen here. So there's not much what I can do except for to write this in the other log form. So the other log form, if I have something in the form of b to the x equals y, I can write that out as log base b of y equals x. You're my base, you are my x, you are my y. So I can write this out as log base 3 of 5 equals 3x. Now, I have no clue what log base 3 of 5 is. And if I run to my calculator, I'm lost, because the calculator's log is log base 10. This is log base 3. I have to use the change of base formula. And if you're like, what's the change of base formula? Let me quick show you. Change of base formula says if you have log base b of m and you need to throw that into your calculator, type out regular log of m over log of b. And so this is log invisible 10, and then this will work. So this is what I have to do. In my calculator, I have to type out log of 5 divided by log of 3. That gives me a gross number. That's going to equal 3x. So once I get that gross number, what I'm going to do is divide that gross number by 3, and that gives me an x. So one more time, I'm going to type in log base 5 divided by log of regular 5 divided by a log of 3, get a gross number. Divide that gross number by 3, and that'll give you my x. Okay, log of 5 divided by log of 3. There's my gross number. Divide that by 3, and my answer is going to be 0.488. And I'm going to round it there. All right, so after all of that, I got 0.488. Terrific. A logarithmic function g is created by transforming the function f of x equals log base 5 of x such that g of x is 1/2 f of x plus 3 plus 2. Find inverse g of 3. All right, this is going to be a doozy. First things first, it tells us what f of x is. It's that. Then they want us to do half of f of x plus 3 plus 2. So let's do this. Let's find out what f of x plus 3 is. Okay, won't take long. If f of x is log base 5 of x, then f of x plus 3 is log base 5 of x plus 3. NBD, as the kids say, for no big deal. Now, g of x is now going to be 1/2 of f of x plus 3, or log base 5 of x plus 3 plus 2. They want me to find the inverse and then plug in 3. So this is how I find the inverse. I don't like the g of x there, it throws me off, so I'm going to rewrite this as y equals 1/2 log base 5 of x plus 3 plus 2. Step number 1 in finding an inverse is swap your x and y values. So now I have 1/2 log base 5 of y plus 3 plus 2, and now I have to solve for my new y. First thing I'm going to do is I'm going to subtract 2 from both sides. So I have x minus 2 equals 1/2 log base 5 of y plus 3. You're now gone. I have to get rid of that half, so why don't I multiply both sides by 4, by 2 I mean, multiply both sides by 2. That crosses these guys out, and I distribute on the left. So I have, let me write it up here because I'm running out of space, 2x minus 4 equals log base 3 of y plus 3. Now I have to solve for y, and y is inside of a log. That's no good. I have to get rid of that log. How can I get rid of a log base 3? Take 3 to the of both sides. Okay, take 3 to the of both sides, and that gets rid of the 3 in the log base 3. And now I have 3 to the 2x minus 4 equals y plus 3. If I subtract 3 from both sides, I now have 3 to the 2x minus 4 minus 3 equals y. Well, it just so happens that y is now my g inverse. I got y all by itself, so now I can call it g inverse. Great. Gross. Not the end of the world. Because what I have to do now is I have to take the 3 that I'm given here and plug that 3 in. So that is going to be 3 to the 2 times 3 minus 4 minus 3. 2 times 3 is 6. 6 minus 4 is 2. 3 squared minus 3 is 9 minus 3, 6. So after all of that, it's a pretty gross problem, but we did it. When considering the equation log of x minus 3 plus log of 5 is greater than log of x plus 9, which of the following domains is our initial restriction? Basically what that means is if I look at these guys, there's certain numbers I'm not allowed to plug in. And that has to do with u, and that has to do with u. Well, what am I not allowed to plug in? Well, anything that makes the log negative. Negative. So I'm not allowed to plug in 3, but I'm also not allowed to plug in anything less than 3 or equal to it. So I'm not allowed to have anything that's no good. So in this case, my domain for this guy is I'm only allowed to plug in things that are greater than 3. Okay? Because those are no good. I'm not allowed to plug in -9 or anything less than that, which means my domain for this guy is going to be -9 and including -9 because I'm not allowed to have the log of a 0 and bigger than that. Now, it just so happens that if I can't plug in -9, this guy covers that. Right? If I'm not allowed to plug in 3, great. That's included in this guy right here. So this is going to be my ultimate guy. If I were to just choose that, you are saying I'm allowed to plug in 2 and 1 and 0, and you're not allowed to plug those in. But if you start out with that, that encompasses everything. Look at that. Express y as a function of x. A, b, and c are constant positive numbers. All right, so what they want me to do is they want me to get y all alone by itself. Issue number 1 is y lives inside of a log. That's no good. Not only do I have a log on the left, I have a log on the right. So this is my first step. I'm going to add log c to both sides. I'm going to add log c to both sides. Now, even though it doesn't look pleasant, this is good news because I have log of y minus a plus log of c. Both of these guys are invisible base 10s, which means you guys combine. When you add logs of the same base, multiply the insides. So when I multiply the insides, I have log base invisible 10, which you know what, I will write out because I know I'm going to need that. Multiply c to y minus a, which includes the distributed property. So this becomes cy minus ca. That still equals bx. Now, why did I write that 10? Well, that log is still in the way, and I need to isolate that y. And so in order to get rid of a log base 10, I could take the 10 to the of both sides. 10 to the of both sides. That allows me to cross these guys out. That leaves me with cy minus ca equals 10 to the bx. Is y all by itself? Nope. Let's add ca, or as Arnold Schwarzenegger would say, California. He was the governor. The governator. What is that? 10. How do they want me to write it out? It doesn't really matter. It looks like 10 to the bx plus ca. Divide everything by c, divide everything by c, divide everything by c, because it looks like they want to keep these guys separated, just like that one song from the 90s. I think that was Offspring. I have 10 to the bx over c plus a, and that gives me a. Not that pleasant of a problem. Not fun at all. But it allowed me to do all these fun log rules, and I did it. Solve the equation log base b of a plus log base b of 5 equals c for a. So this is really no different from a regular, let's solve this log, but I have all these letters to deal with, so let's deal with them. A lives inside of a log. No matter, these two logs share the same base and they're being added to each other. So whenever you're adding logs of the same base, multiply the insides and you become log base b of a times 5, which is 5a. That's going to equal c. Now I have to isolate the a, but the a lives inside of a log, and I need to get rid of that log. So if I have a log base b in the way, take b to the of both sides, and that'll allow these guys to cross out. Drop down the 5a, drop down the b to the c power. I need to get a all by itself, so divide both sides by 5, divide both sides by 5, and a is going to equal b to the c over 5, which is u. Gregory and Spencer began a fitness routine in order to build their upper body strength. Gregory's gains in muscle mass can be modeled by the function g of x equals 50 times log base 2 of x, where x is greater than 1. Represents the number of days he has followed the routine, which means more than 1 day. Spencer's gains for the same period of time can be modeled by the function s of t, or x of x, equals 20 times log base 4 of x. After day 1, Gregory has gained more muscle mass than Spencer by a factor of what? So after day 1, I'm assuming means day 2, dose. All right, so let's take a look at Greg. Let's take a look at g of x. Let's take a look at Gregory. Okay, if I want to find out what g of 2 is, there's not really much to think. Okay, you just say g of 2 is going to equal 50 times log base 2 of 2. Now, before you freak out and say, like, how am I going to do that? I don't have a calculator. First off, log base 2 of 2 is 1. So he is 50 times 1, which is 50. So whatever that means, 50, I don't know, megatons, whatever. That's what Gregory is. Now, let's take a look at Spencer. Okay, let's take a look at Spencer, s of x. This is going to require a little bit more. In order for me to find s of 2, I have 20 log base 4 of 2. Now, I don't have a calculator. I can't do log base 4 of 2. But this is what I can do. I could use the fact that there exists a little guy called the change of base formula. Change of base formula says, actually, let me start it over here. If I have log base b of m, I can turn this into log base whatever I want. So log base t of m over log base t of b. Now, usually when we do this, we whip out our calculators and just do regular log and let our calculators do the work. I don't have a calculator. So in order for me to do log base 4 of 2, I'm going to be a little creative. I'm going to choose log base 2. So I'll do log base 2 of 2 up here, because that turns into 1, remember, over log base 2 of 4. And some of you might be thinking, I can't do that. I can't do log base 2 of 4. I can if I do 2 squared. You see, this becomes, 20 is still there, by the way. Log base 2 of 2 is 1. Log base 2 of 2 to the whatever power drops down the whatever power. So log base 4 of 2 just turns into a half. Interesting. 20 times a half is 10. So after day 2, Gregory is 50 whatever, Spencer is 10 whatever, and the question is how much more muscle mass by a factor of what? Well, 50 is 5 times more than 10. So that'll be our guy. Kind of a not fun problem, very difficult in my opinion, but yeah, we did it. The function g of x equals a times f of x results from dilating f of x equals log base 2 of x by a factor of a. All right, so g of x is just a times f of x, and f of x is that. Why don't I just write that out? Why do I have to complicate things? G of x is going to equal a times log base 2 of x. Use the table of values below to determine the value of a. Well, I'm not good at finding logs off the top of my head, so why don't I do this? Why don't I change this into its other form, its exponential form? I'm going to just turn g of x into g because that'll make my life easier. And then I'll plop a right there, okay, because I'm allowed to use that formula that says if I have a living in front of a log, I can make it an exponent. So now I have log base 2 of x, okay? If I take 2 to the, of x to the a, that was a close one. If I take 2 to the of both sides, right, that crosses out, and now I have 2 to the g power, or, g of x, is going to equal x to the a power. Now that I have this information, I'm going to use this table to determine what a is. So let me just pick u. Let me pick u. Okay, x is 4. Okay, so 4. A is what I'm looking for. 2 is 2, and g to the x is 10. Well, that's very unpleasant. I don't know what 2 to the 10 is, but you know what I can do? I can rewrite 4 as 2 squared. Multiply these guys, and you have 2 to the 10 equals 2 to the 2a. If 2 to the 10 equals 2 to the 2a, then 10 equals 2a. Try saying that really fast. So if 10 is 2a, divide both sides by 2, and a is 5. The function ln of a of t over a equals kt models the amount of a particular radioactive substance that remains after t hours, where a is the initial amount of the substance, k is the rate of decay. And so a of t would be the total amount when all is said and done. If 24 grams of the substance decay to 8 grams after 36 hours, after approximately how many hours would the initial amount have been reduced to a half? Ugh. All right, so this is going to be gross. This is going to be really gross. 24 is what I start out with. So A is going to be 24. All right. My amount after 36 hours, so T is going to be 36. My total amount is going to be A of t is 8. My job is to find the rate so that when I do find the rate, I can do part 2 here. So I'm kind of doing 2 of these problems in one, which means I'm probably going to have to whip out the calculator twice. NBD, as the kids say, NBD. ln of A of t is going to be ln of 8 over A is 24 equals k times 36. So this is what I'm going to do in my calculator. In my calculator, I'm going to type this guy out. Okay, I'm going to type that guy out right there and get some gross number. Once I get that gross number, I'll have 36 equals k. I'll divide both sides by 36, and then k will equal something brand new. So one more time, I'm going to run to my calculator and find out what ln of 8 over 24 is, get a number, divide that number by 36. That gets me k, which is going to be my rate of decay, something that I'm going to need in order to do part 2 here, right there. Right, ln, there you are, of, what was it, 8 over 24. So let's type that out. It's going to equal a gross number. There it is. Take that number, divide it by 36. And our k is going to equal negative 0.30517, blah, blah, blah. So we'll actually use all of those numbers until we hit that double zero, just to keep things as accurate as humanly possible. All right, so after doing that, we got a pretty gross number, negative 0.030517. Then it was like 008, but I'm going to stop right there. Now that I know k is that, I can go back to this original equation to answer part 2. Part 2 says, how many hours would the initial amount have been reduced to half? Okay, so ln of, now remember the original amount was 24. I'm no mathematician, but half of that is 12. My job is to find t. I now know what k is, so negative 0.030517 times t is going to help me do that. So very similar to what I did over here. I'm going to type this guy into my calculator. When I type this guy into my calculator, I'm going to get a gross number. Then I'm going to divide that gross number by another gross number, which is this guy right here. And when I divide that gross number by a gross number, I get a gross number which represents how much time it takes for this substance to get cut in half. So let's go away and do that again. All right, so this time I'm going to take ln of 0.5 or a half, however you want to write it out. Right. Hit enter on that guy, and it's going to give me that number, 0. Who cares? Negative 0. Who cares? What I'm going to do is I'm going to divide that number by negative 0.030517, hit enter, and I get something to the tune of 22.713, blah, 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 blah. So let's go back, write down our final answer. We can be done with this terrible problem. All right, so after we did that, we ended up with 22 we rounded it to 713. It was like 7134 or whatever. So 3 decimal places is standard for AP, so we'll go with that. Gross. The table presents values for a function f at selected values of x. A logarithmic regression is used to model the data. What is the value of 4.5? So this is what we're going to do. Okay, no work to show here. I'm going to run to my calculator, and I'm going to use ln reg for this guy. It's going to spit out an equation. I'm not even going to write that equation out because I'm going to store it in my phone. And once I have it stored in my phone, I'm going to find the value at 4.5. Okay, so let's go off to the side and do that. All right, so let's do ln reg. We're going to go to stat. We're going to go to edit right away, and we're going to plug in our x values. 1, 3, 5, nope, 7, 9. They had to go out of order on us. 44.9, 37.9, 32.4, 30.7. Now we are using logarithmic regression. So we're going to go to stat, we're going to go to calc, and we're going to use ln reg. So I'm just going to hit 9. Now, not only, I don't need to write out the equation. It's not asking, hey, what's the equation? It's asking when the value is 4.5. So what I'm going to do is I'm going to store my regression equation into y equals so that I can use that equation in a little bit. So I'm going to go there. I'm going to go to vars. I'm going to go to y vars. I'm going to go to function, and I'm going to go to y sub 1. So whatever this gross equation is going to be, I'm not going to bother writing it down because now it's stored in y equals. So since it's stored in y sub 1, and my job is to find what happens at 4.5, I can hit second calc and type in that value of 4.5. So let me hit enter. It's going to graph it for me, even though I can't see anything because the numbers are above 10. 4.5. Enter gives me 35.225, which is going to be A. So let's go back and circle it. All right, so that's ln of reg for you. You got A. Pretty standard. I mean, if you've seen my videos, we've done a lot of regression. ln is just another one to throw onto the pile. The amount of bacteria in thousands found on the beach has been steadily declining. Let's go to the beach, beach. Nicki Minaj. Scientists want to create a regression model to show the number of bacteria as a function of years. Calculator problem? Absolutely, because we are going to create a logarithmic regression equation that could model this situation. That requires the use of a little thing called ln reg. So what I'm going to do is I'm going to run to my calculator, type that in. I'm going to get an absolutely awful equation, but let's see what happens when I do that. All right, let's start out with doing our ln reg. We have stat edit, and I'm going to type out 1, 2, 3, 4. I think I can handle that. That matches up with 9.9, 7.8, 6.7, and 5.8. Okay, now ln reg is done by hitting stat, going to calc, and we can go down or we can just hit 9 for ln reg. Now, for part C, I'm going to need this equation again. So what I'm going to do is for a store regression equation, I'm going to go down there, go to vars, go to yvars, and then hit enter, enter, and now it's going to be stored. But what I have to do is I need to take that guy and write it out. Ugh, and it's gross, but we're going to round it to 3 decimal places. So this is saying y equals 9.885 plus negative, so minus 2.939 ln of x. So let's write that out. All right, so let's get rid of that ln reg because we're going to need all the space we can get to write out this awful formula. Y equals 9.885 minus 2.939 ln of x. Now I'm going to use that for B and C. C is actually a whole lot friendlier than B, but that's not the order that we have. B says how many years until there's 2,000 bacteria, which means we're solving for X and we're going to let Y equal 2. So let's do that. 2 equals 9.885 minus 2.939 ln of X. I'm going to subtract both sides by 9.885. 9.885. Don't need a calculator quite yet. I can handle this one. Negative 7.885 is going to equal negative 2.939 ln of x. I'm going to divide both sides by negative 2.939, negative 2.939. Now, I'm going to not do as much right now because it's a pain in the butt to keep going back and forth and making these videos when I go to my calculator. So what I have right now is I have that fraction right there, negative 7.885 over negative 2.939 equals ln of x. If I take e to the of both sides, that crosses out, and now I have x equals that number right there. So I'm going to go off to the calculator and find out what that number is right now. All right, part 2 of this problem has me finding out what e to the gross fraction is. So the e to the button is second ln, how convenient. And I'm going to have my open parentheses. It's going to be negative 7.885 divided by negative 2.939. Let's close those parentheses. Let's hit enter, and we get 14.627, blah, 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 and we'll round it to 14.627 years. 14.627, which means how long will it take? 14.627 years. So I don't know, somewhere in June? Pretty unpleasant. C is a lot more pleasant because now all I have to do is just plug in 6. So y of 6. And what I can do is I can quick run off to my calculator. And since I already saved this in my y equals, all I have to do is just go to the table and find out what happens when y is 6. All right, so as you may remember from part A, we stored our equation into y equals. Okay, so now all I have to do to find out the value at C is I could either go to second calc trace, type in value, or I can go to my table, run down to 6, and find out that it's 4.619. And since it rounds to 3 decimal places, that's all I've got to do. Ooh, 619, Rey Mysterio. He's a wrestler, a luchador. And you get 4.619. This, of course, is in thousands, so we'll say 1,000. It may have been easier if I just wrote out 4,619, but you know what? I'm sticking with the bit. So there you have it. Gross. The table gives values for a function f at selected values of m. Which of the following graphs could represent these data in a semi-log plot where the vertical axes are logarithmically scaled? That's a terrible word. All right, a semi-log plot basically takes a coordinate plane and makes it look different so that when you graph something that's logarithmic, you end up with a straight line. Okay, semi-log plots, basically what it looks like is the vertical part of it is you'll have a straight line, and then it gets smaller, and then it gets smaller, and then it's like really small like that. You guys are just regular old graphs. So let's get rid of you, and let's get rid of you. If you look closely and squint your eyes, you can see this process where you have all this space and then it gets closer and stuff like that. And the same thing happens for this one right here for D as well. Here's the situation though. The goal and the purpose of a semi-log plot is for you to demonstrate a logarithmic equation as a linear equation. So if I look at where these points are, C follows these points, okay? So like here would be 1, and then like, you know, that would be, I guess that if that's 10, then that would be my 18, and then 2 would be my 30, and 3 would be my 58, which happens up here. And my dots are represented in a straight line. Looking at these numbers, you know that these numbers are not linear. This guy gives you something that's curved. Again, one last time, the goal of a semi-log plot is to represent logarithmic data as something that looks linear, and C is the guy that does that. Function f is an exponential function. Which of the following graphs could represent f in a semi-log plot where the vertical axis is logarithmically scaled? All right, so an exponential function is basically something that follows a curve. The goal of a semi-log plot, and as you can see by these pictures, you kind of have like this space, and then that space tightens up, tightens up, tightens up. The goal of a semi-log plot is to make an exponential function or a logarithmic function appear linear. 1 does that because that appears linear to me. 2 doesn't because that appears not linear to me. And 3 does that because that appears linear to me. So the answer for this one is going to be 1 and 3, because the goal of a semi-log plot is to make exponential functions or logarithmic functions appear linear, and those are the guys that do just that.